Good afternoon, my friends. Good afternoon, my warriors. Welcome to the last minute revision session of modern physics with me, Shreyas, your physics master teacher at Vedantu. Hello, Alia. Good afternoon. Hi, Gokulan. Hi, Tarun, Pranati, Zaid, Ashita, Veera. So, Naga, we will be discussing the theory with the questions. That's the best thing to do. If you start with the theory like completely, then it will take a lot of time. So I would advise you, Naga, first try to understand, and all those people who are expecting theory in detail, see first which questions you are able to solve, see which questions you are not able to solve, and based on that, think where are your weak points and only revise those concepts. There is no point wasting time revising everything, alright? Hello Pranjal, hello Vicky Reddy, hello Kashish, welcome, good afternoon everyone, my lovely warriors out here. Yeah, nice to see all of you out here. So, hi Siddharth, hello, good luck. So, in case you are new to this channel, do not forget to first of all smash the like button and hit the subscribe button out there, because only then you are going to get more papers, more solutions, more mock tests, more revision sessions, more formula sessions for all of you. Hello Hindu, hi Satvik, hi A2 Motivational, hi Nichal, welcome aboard. So, if you have not yet subscribed, do that, because you're going to get a lot of things. And if you have subscribed, do not forget to show your love, pledge your support to our channel by hitting the like button. Yeah. Now I'm much better, Janath. Yesterday I had conducted classes for almost I think 8 hours or something, 8-9 hours, plus I had couple of meetings, so my whole day was occupied. So by the end of the evening, I was completely gone. My throat was very bad. Hi Jayasurya, hi Chirag. Yep. So that's why I was not able to conduct the session in the morning. If I would have taken it, I'm pretty sure I wouldn't have been able to conduct this. So what I've done, the electromagnetism session, I have kept it on Friday. The one which I was supposed to take in the morning, I kept it on Friday. Today we are doing modern physics. Now remember, in modern physics we are also doing semiconductors, communication system, logic gates, nucleus, everything, all the topics being done today. In fact, I was earlier planning to do semiconductors and communication separately, but then I thought we can do all of it together in modern physics. We can save some time. And yes, we are going to have mock tests and complete physics revision sessions like formula revision session and short 60 and all of that coming on Monday. All right. I'm very good, Karthi. Thank you, Alia, for all the love. Oh my God, why is your heart broken? Hi, Saurabh Shao. Thank you for putting up those diamonds and those yellow hearts. Wow, Ayush is from Nepal. Welcome aboard. So OP hoga mechanics, instead of mechanics part 2, we'll have mock test bacha. Okay. So this is the timetable, and if you still want to join the test series and our crash courses to improve your rank, please do that right now. Even in the last few days, in the last 10 days, things can change. Even if the crash course helps you improve the marks or your percentile by even some 1 percentile, 2 percentile, or even maybe sometimes 10 percentile, depending on which range you are in, use that. Make sure that you follow all the test series, mock tests and discussions, because there is, it's a proven thing that when you are in Vedantu, then your ranks, your marks are much better than when you are not in Vedantu. If you see JEE Advanced, CBSE, 10th, 12th results, it all shows the same thing. So you can use my discount coupon code SHCC and avail the 60% off offer. So you get it for 4,000 rupees. That's the crash course. The link is in the description box below. So let's start with dual nature. So are you guys ready, guys? Are all my warriors ready? Hi Jila, hi Prudvi, hi Mastermind. So mastermind basics se nahi hoga. The thing is, understand, this is not a theory session. Please keep this in mind. This is a problem solving session. If you are going to go through theory at this point of time, that's a wrong move, bacha. There was a lot of time to actually revise theory. We have been conducting Zero to Hero series, rank booster series before this, where we used to revise the theory in short and then do problems. Now it's too late to actually start from theory. That will be wrong move. A lot of people do that. That's wrong. Do not do that. It's a problem. Know it. We will try it for some other time, bacha. Right now, please you try to somehow use probably a plugin, or probably invert those colors and try to change it to dark mode from your side. It takes a lot of work to change all our sides to the dark mode. So we'll try to do this. I have kept it in mind. It will happen slowly. For today, let's get going. Okay, so everybody is ready. Hello Tornado, hello PSV, hello Chris, hello Abhi, hello Numer. Yeah, so let's start with dual nature of matter. And here is the first question coming up on your screen. So there are two particles, like you can see, and they move at right angles to each other, and their De-Broglie wavelengths are lambda 1 and lambda 2. Now if you recollect, what was De-Broglie wavelength? Every matter, every particle has also a particle-like behavior. Wave-like behavior. So that wave-like behavior has an associated wavelength that is called as the De-Broglie wavelength. Okay, so every particle has wave-like behavior. Even waves have particle-like behavior. So the particle suffers perfectly inelastic collision. That means they stick to each other. The De-Broglie wavelength of the final particle will. Oh my God! Why is the answer there? The answer shouldn't have been there. Oh my God! The first questions. Yep. Oh my God. Anyways, so probably the answer shouldn't have been there. Anyways, I think I just clicked my board by mistake. But anyways, let's try and solve this. So the point over here is not to just get to the answer. The point over here is why you're attending over here is because you want to know how to get that. So let's do this. So there is a particle. It is coming like this. There is another particle. It is coming like this. This has wavelength lambda 1, wavelength lambda 2. And when they combine together, form a big mass, their final momentum will be here, and their final De-Broglie wavelength is lambda. Now, remember, momentum should be conserved. The momentum is conserved in that collision. Now, what is the initial momentum? Think about it. And what is the final momentum? Think about that. The initial momentum is not P1 plus P2. Remember, momentum is a vector quantity. So if momentum is a vector quantity, this momentum and this momentum together will give you a resultant momentum like this. And that would be root of P1 square plus P2 square. This is, understand, the resultant. It's the resultant initial momentum. And the momentum, okay, final will be just, let's say I put it as P. Now what is P1 and P2? Well, P1 is nothing but h by lambda. Everybody knows lambda is h by P. So P is h by lambda. So I'll put lambda 1 square, and here we'll have h by lambda 2 whole square, and this is nothing but h by lambda. Now square both sides and remove the roots and also cancel those h's. So what will you get? 1 by lambda 1 square plus 1 by lambda 2 square is equal to 1 by lambda square, which is option A. Yep. Yes, great. That's how it is. Yep. Thank you, Mohammed. Thank you, everyone. I'm very good, Jugudi. Yep. So yes, right now this same session is telecasted in both the channels on JEE Enthuse as well as Catalysis. So even if you are a Catalysis user or if you are a JEE enthusiast, the same session is running parallelly in both the sessions. Yeah. Okay. So that's how you solve this. The idea was to conserve momentum. That's the first concept. Second concept, momentum is vector. Just don't add momentum P1 and P2. It's a vector quantity. So find the resultant momentum and then equate it to final momentum. So that's the way you do it. And the third step was obviously the formula. Lambda is h by P or P is h by lambda. Use that. So solving, you will get it. Okay, cool. That was the answer. Let's see the next question coming up on your screen. My voice is much better. Thank you guys for all your concern. I'm feeling much better. Thank you, Yalini, and all others asking this. Okay, cool. Let's get going to the next one. Praneet saying A already. I don't know. I'm very good, Samla. Thank you so much. Hi, Thalsim. Welcome aboard. Okay. Pratik, I think you should just check your internet settings. Number 2, check your resolution. Probably you can lower the resolution a little bit and probably watch it. Okay. Let's see whether we can solve this question. So there is a particle of mass m charged. It's accelerated by some potential difference. Another particle of different mass, different charge, accelerated by different potential difference. The ratio of the De-Broglie wavelength is, let's see. Thank you, Ritesh Bacha. Yes, Abhi, you can only take crash course. The link is there in the description. It's only for 800 bucks. You can use my coupon code SHCC and you'll get it for only 800 bucks. Only the test series. You can get it. Okay, so let's see how do we do this. Okay, now remember lambda is h by p. Now momentum is nothing but root of 2 times m times kinetic energy. Where did this formula come? Remember, kinetic energy is p square by 2m. That's a standard formula. Momentum square by 2m is kinetic energy. So momentum is 2 km root of that. Okay, but don't leave it over there. Remember, it has been accelerated by some potential difference. So if you take a charge and if you accelerate it by v volts, understand the kinetic energy that it will get is q into v by the end of the acceleration. Hence, this can be further written down as h by root of 2m charge into voltage. So that's the final form I got. So now it will be easier to compare. Always see what is asked, see what is given. Masses, charge, voltage. So bring it in the given terms. Only then it's better to solve the problem. Now the question here says lambda A by lambda B. So lambda A by lambda B means divide a wavelength for A and wavelength for B. You will see H will get cancelled. So what will be remaining? For A, you will see 2 mass of A into charge of A into voltage of A. Okay, and for B, the terms will come on the top because it's inversely related. 2 times mass of B into charge of B into voltage of B. Okay, now think 2 will get cancelled. It's clearly mentioned that the charge is same. The charge is same. Only the masses are different, voltages are different. Okay, so let's see what do we get. Mass of B by mass of A. Mass of A is m, mass of B is 4m. Okay, so B by A will be 4m by m. You can see that 4m by m. Q by Q will anyways be cancelled. VB by VA. VB is 2500 and VA is nothing but 50. Okay, so this is nothing but 50. So guys, see what and all will get cancelled. This 0, and this will be nothing but 50. And this M, this Q, this Q. So 50 into 4, what is 50 into 4? 200. So this will be nothing but root of 200, which is root 2 into root 100, which is 10, which is 1.414 into 10, which is 14.14. Hence, the correct answer is C. This question can also come in integer type as a decimal question. Yeah, you might have to mark it in the form of numeric type. Maybe the options might not be given. Yes. Done? Understood? So remember, you have to mark it till the second decimal or first decimal depending on what the instruction says. Be careful about that. So Devil Man, I have already done it. 0 to Hero series on all these chapters. So please watch the replay, bacha. It's already there in the playlist. Okay? Cool. Let's get going to the next question. So, and yeah, that's the answer. Option C. Okay, cool. Perfecto, says Samla. Yes, PMC. Let's do this. Come on, my warriors. Think about the next question. For which of the following, particles will it be the most difficult to experimentally verify the De-Broglie relationship? For which particle do you think it's difficult to figure out the De-Broglie wavelength? Come on. Hello, Afaf. Good afternoon. Welcome aboard, all my warriors. Shaurya, yes, I will definitely solve all the questions of, we'll try and solve those questions of third and fourth attempt over here on this channel. Don't worry about it. Okay. Hello, Prudvi. Welcome. Some of you are confused between C and D. Think carefully. C or D? Guys, the answer is something which is odd. Think about it. Electron, proton, alpha particle. They are all very small, atomic sizes. They are all atomic sizes. Their momentums, their masses, they are very, very small as compared to this one. This is a big particle as compared to this particle. So obviously dust particle is very small, but as compared to you, but as compared to electrons, protons and alpha particles, it's quite big. Now remember, De-Broglie wavelength is h by the momentum. Now when the momentum is small, lambda is big. It's easy to do experiments, but understand the reverse. If momentum is large, then lambda is very small, then there is hardly any noticeable difference when the lambda is very small. Okay, so when the wavelength is large, you can conduct the experiments, you can observe different phenomena easily, but when the wavelength is small, then it becomes a problem to conduct experiments. So that's why a dust particle or any such big bodies will not have much significance in terms with the De-Broglie wavelength. Generally, you do not associate big particles with their wave nature because it's hardly seen. The wave nature is hardly seen. Only in the quantum world you can see all these effects very clearly. Okay, so let's see the next question. Yep, very good beginner guys, very good Venkat, very good. Chalo, come on. Yeah. So next question. Now there is no option over here, that means it is integer type guys. Okay, let's see if we can solve this. Electron, which has mass m, speed v, is used in a double slit experiment instead of light. Then the fringe width is given by. So what is the fringe width? So two chapters are coupled together. Two chapters. Yes, Hari, we are live on both the channels. Isn't it amazing? Pedada Krishna asking how to score 100 percentile. You should know everything. Your speed should be really fast and you should be really focused, and you should have very good concentration so that you do not even make one mistake. That's all. Oh, no problem, Venkat. We do not differentiate out here. Even if you are from any other institute and if you are coming over here and watching our lectures for free, we are happy to help. I am a teacher. My job is to make sure that you learn. My interest is to make sure that all of you learn from me. That's all, nothing else. Yes, Priyanka, I can see both the chats. Okay, come on. Optics plus dual nature. Yep, let's see how many of you can get this. So, in a Young's double slit experiment, okay, so what you get is a bright fringe here, then a bright fringe here, bright fringe here. So, the difference between these two fringes is called as the fringe width. Fringe width. Yeah. And usually you can use light, but you can also use electrons. Yes, you can also use electrons and you will still see the wave nature. You will see the wave nature of electrons. And when those wave nature of electrons are exhibited, you will see interference pattern being formed on the screen. Yeah, these are not advanced level. These are very simple questions. So first of all, what is the formula for fringe width? Remember, it was lambda d by d. What wavelength is this? This is your De-Broglie wavelength. So that means it is h by p into d by d. But what is p, guys? P is nothing but mv. So it is hd by mvd. So that's the fringe width. That's the answer. Done, done. Yep. A lot of you got it. Very good, Pramesh. Excellent. Hello, Venkat. Very good. Yes, a lot of you got it. But you have to give the answer in terms of Planck's constant, d, m, v and small d. Now what the hell is this d? That's the distance. Okay, in fact, I'll just mark it over here. That's the distance between the screen and the slits. And what is that small d? That small d is this one over here. The distance between the slits itself. So that's the value of small d. Yeah. So if the values are given, if you are given the values, this is a mass, this is a speed, then you have to substitute all the values of d, small d, h, m, v, and then get the final answer and put it in the boxes or type it out, whatever the integer type answer is. If it comes as option, then you probably have to just choose which is the correct expression. Alrighty, let's get going. Are you guys loving these questions? NEET difficulty will be obviously easier than the JEE Mains bacha. So if you do JEE Mains, if you can crack JEE Mains, NEET will be cakewalk. You can almost get full score in NEET. So those of you who prepare for JEE, if you give NEET, I mean, it will be like a cakewalk for sure. Thank you, AAA squad. So those were the questions on dual nature. Are you guys now ready for photoelectric effect? Are you guys now ready for photoelectric effect? Yes. Look at that, a lot of fire and hut and sparks less. Yes, very good Sandhya, very good Sundar, very good Prudhi, no problem Aditya. Yes, thank you Gopichan, Tornado, Sai, Janat. Let's get going to photoelectric effect. So here comes the first question, but before that, what is photoelectric effect? Let me quickly brush up those concepts. When light of high frequency falls on a metallic surface, then some energy goes in taking out that electron or knocking out the electron from the metallic surface. That energy which is required to knock out the electron is called as the work function. The remaining energy of the light, which first of all some energy is used in just taking it out, what did I call it? Work function. The remaining energy goes in the energy of the electron, that means kinetic energy. So the light energy goes into two things, removing the electron, that's work function, plus kinetic energy. If you apply some voltage difference, you can either accelerate or you can decelerate it. So when you accelerate it, more electrons will come here and you will see the current in the circuit will increase. But if you apply reverse voltage, then the electrons which are coming here will be decelerated. They will stop, and if they get stopped and they are not able to reach on the other side, that voltage is called as the stopping potential. That's how it is. Okay, so if you apply reverse voltage, those electrons will decelerate, stop and go back. If you apply a certain voltage beyond which none of those electrons are able to reach here, that's the stopping voltage. And we see that if the frequency is higher, if the light frequency which is incident is higher, then the energy of the electrons is also higher. So energy, kinetic energy of those electrons is higher because more energy will be remaining after knocking those electrons out. And if you have more light falling onto it, then more electrons will be knocked out. If more electrons are knocked out because the light incident is more, that means more electrons will flow through the circuit. That means the current will increase. Yes. Rishi, thank you, Bacha. My throat is much better. I took rest in the morning. Okay. Come on. Let's get going to the next section, and that's photoelectric effect. And here is your first question. In a photoelectric effect, the graph of stopping potential V versus reciprocal of wavelength obtained is shown in the figure, and the intensity of the light is increased. Then which of the following will happen? Thank you, Balanganesh. Thank you, Pramesh. My throat is very much better because of the rest I took in the morning. Thank you guys for all your concern, and thank you guys for understanding. But don't worry, the morning session I'm going to conduct it on Friday morning. Okay, so don't worry, you're not going to miss anything. Yes, Suryajit, I'm going to take semiconductors and communication also. Earlier I was planning to take separate session. I was planning to take it on Friday. Instead, what I did, the Friday's semiconductor and other things, I clubbed it here so that we can revise entire modern physics in one shot. Yep, come on, my warriors. Hello, Samyukta, welcome aboard. Very good, beginner guys, everything is clear. Come on, my warriors. Thank you, Padma, for all the love from Tamil Nadu. Okay, what is the answer? A lot of you are saying D. Yes, very good. The answer is, it is not going to change. The reason is, the intensity of the light, okay, will probably increase number of photons. When it increases the number of photons, what happens next is the electrons number will increase. The number of electrons which are ejected out will increase. If the number of electrons ejected out are increased, then the current will increase. So the current will increase, guys. Now, if you see this graph, this is voltage, stopping voltage versus 1 by wavelength. It's got nothing to do with intensity, nothing to do with number of electrons, nothing to do with number of photons, nothing to do with current. So this graph has no such parameter which is getting affected, either the photons or electrons or the current. So hence the graph won't change. Understand? If the graph was versus current, yes, the current will increase. So there is no current in this. So obviously that's not the answer. Some of you might be some very smart people and you will be like, sir, Ohm's law, sir, if current increases, Sir, then voltage will also increase because voltage is IR. Though some brainy people are there, very smart people are there. Sir, if current will increase, voltage will increase. So if voltage increases, this graph will go up and hence the graph will shift. No, 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 no. This is not voltage. This is stopping voltage. Be careful. This is stopping voltage, stopping potential. So to stop those electrons from going to the other side. So understand, if you increase number of electrons, more electrons will be ejected. And the stopping voltage, that won't change. So is that clear? Yeah, Jagdish, I am much better. Thank you. Yes, Hari. Yep, 55.5. That's cool, right? Thank you for all your support and love. Okay. How many of you are those brainy and smart people? Nobody was brainy and smart out here? Okay. Thank God. Great. Hi, Google. Welcome. Good afternoon, Ashraf. Archit, I doubt, Bacha. I don't think they want to really play with your mind so much. Already you guys are stressed. In fact, if I was the paper setter, I wouldn't keep it very tough. I wouldn't keep it very easy also. I would keep it normal level like how it was in Feb and March, or maybe somewhat plus or minus 10% from that. Because come on, you guys are already mentally stressed because of this pandemic. It doesn't make sense that the paper should be too difficult from the level it is. Okay, cool. Let's see how many of you can get this. Okay, Yalini says I don't have brain. Good afternoon, everyone. Okay. Hi Gokul, come on, figure this out. There is a surface of some metal and it is first illuminated with some light of 350 nanometer. Then by a light of 540 nanometer, it is found that the maximum speed of the photoelectron in both the cases differ by a factor of 2. Now which one is 2 times more? That is not given. You figure it out. Who is 2 times more? That's not given. Please read the question. The work function of the metal is close to. Thank you Alpha for all the love from Kerala, Bacha. Okay, let's see how do we do this. First of all, the photoelectric equation is energy of a photon. The energy of a photon goes into the work function, okay, the work function plus the kinetic energy. That's the photoelectric equation. Now what's the energy of a photon? It's hc by lambda is equal to work function plus the kinetic energy. Now kinetic energy is half mv square. Now it's given that the maximum speed is different by a factor of 2. So who will have more speed? Who will have more speed? If RHS is more, if this term is more, RHS is more, LHS should be more, that means the denominator should be less. So lambda should be less. Who has lesser lambda? 350 or 540? Obviously 350. So this guy has more kinetic energy. Understand that. So let me be very clear about this. So if I write this as lambda 1, which is 350, this velocity should not be just v, it should be 2v whole square, because the speed is twice as that of the previous one or the other one. I hope this is clear. The one which has more speed, more kinetic energy will have more energy. That means wavelength will be less. So 350 has 2v speed and 540 has v speed. That's the catch. A lot of people will make a mistake here. The next step is hc by lambda 2 is 5 plus half m, and this will be v square. So you can see the factor is 2. Yep. Now modern is very scoring, bacha. It's very scoring. Venkata, we are revising the theory while we solve the problems. Yeah, so that's what we are doing. Okay, now let's see what do we get next. Now from this, what will I get? I will get, check this out, this energy, which is 4 times half mv square, will be hc by lambda 1 minus 5. And from here, I'll get half mv square is hc by lambda 2 minus 5. Now obviously we can divide both of them. Let's divide both of them. Divide this and divide this. Half mv square goes, so only 4 will be remaining. So 4 by 1 is hc by lambda 1 minus 5 divided by hc by lambda 2 minus 5. Now cross multiply. So if you cross multiply, what will you get? 4 times hc by lambda 1 minus 4 phi is equal to hc by lambda 1 minus phi. Rearrange. Okay, just oops, sorry, I think this was lambda 2, my bad, this was lambda 2. Okay, so rearrange. So take the value of 4 phi over there. Okay, take the value of 4 phi over there. So you'll get 4 hc by lambda 2 minus hc by lambda 1 is equal to 4 phi minus phi is nothing but 3 phi. Therefore, phi is equal to, check this out, 3 goes down, hc is common, so hc by 3, okay, hc by 3, and we will have 4 by lambda 2 minus 1 by lambda 1. Yep, this is what we are going to get. Now, the only thing remaining is just substitution, guys. If you have realized it by now, you just have to put the values. Oh, even this is given 1240 by lambda in in nanometer. Okay, is the wavelength in nanometer? Yes. So this will be 1240 by 3, 4 by all the wavelengths, put it in nanometer. So what's the wavelength 2? Okay, so it is nothing but 540, and here you have minus 1 by 350. So solve this, guys, and you're going to get the answer. See what do you get? See what do you get? See if you're getting close to 1.88. See if you're getting close to 1.88. Yep. Understood? Thank you, Kartika, so much. All right, Venkata, cool. Thank you, Kirtana. All right. Okay. So, Kirtana, I have already made a video on which chapters are very scoring and sure shot. Just few days back, I had made that video. Just check it out. Sure shot topics for PCM, for the upcoming mains attempt. All right. Let's get going to the next one. So, if this is clear. So, little bit of calculation. I will put this, in the easy category, but lengthy. This is the category. It's lengthy, little lengthy, and it is also going to come in the tricky category. See, it's easy and tricky. Why is it easy? Because you just have to play with the formula, nothing else. The reason why I told you guys it is tricky is because this factor 2, people get confused over there, whether to put 2v in the first wavelength or in the second wavelength. So it comes under this category, easy, lengthy and tricky. That's all. Okay, let's get going to the next one. And there we have, okay, fine. Yeah, calculative is also, that's why I put it as lengthy. Okay. Beginner guys is asking how to do calculation of decimal values. You should have, without calculator, man, you should have been used to without calculator all your life. If you are using calculator throughout your life, it's going to be a problem. Now I cannot sit and teach multiplication, division. You have to just be used to that. So I cannot say this is how, there's no one line answer. Just, it's a matter of habit. You cannot change it in 1 or 2 days. Okay, let's see how can you do this. The maximum velocity of the photoelectrons emitted from the surface when light of frequency falls on a metal is given, and if the incident frequency is changed to thrice the original one, what's the new maximum speed of those ejected electrons going to be? Sohan, we are doing unit wise, bacha. These are all one shot big marathon sessions. Imagine me doing one shot for atomic structure, one shot for semiconductors, one shot for dual nature. Instead of doing 3 one shots separately for 45 minutes, I'm doing all of them together, in a marathon, and we call it as a unit mock test or unit one shot marathon series. Yeah. Rutvik, formula revision session is also there, bacha. Don't worry, it's going to come on Sunday. Yeah, don't worry about it. Okay, so how do we do this question? The maximum speed of a photoelectron when light of frequency nu falls on it. What are we going to do, guys? Okay, first of all, h nu is equal to work function plus, work function plus half mv square. Photoelectrons are ejected, half mv square. This is the first time, it's v1, or let's say just what's the speed? The maximum velocity is v, right? Okay, so I'll call it half mv square. Instead of confusing this, I'll put it as f. So hf is 5 plus half mv square. That's the first time. Second time, the frequency is 3 times. So 3 times of f is equal to phi. It won't change, but the speed will change. So half m v1 square. How about taking this equation and multiplying it by 3, or just take hf value and substitute it over here? So what will you get? 3 times of phi plus half m v square is equal to phi plus half m v1 square. Cool. So this is 3 phi and that phi will come here. So 3 phi minus phi plus half m v square is equal to half m v1 square. 3 phi minus phi is going to give you 2 phi. Okay, so you're going to have 2 phi plus half m v square is equal to half m v1 square. Now multiply by 2 and divide by m. So it will become 4 phi by m plus v square is equal to v1 square. Oh, I think there was a 3 over here. That 3 was missing. So let me just put 3 over here. Yes, that 3 was there. So that 3 should come over here. Now, here is the thing. If v1 square is this number plus this number, obviously v1 square is more than this and more than this individually. If v1 square is this square plus something, obviously v1 square has to be more than 3v square, because 3v square plus something gives you v1 square. Now take roots on both sides. So v1 will be v root of 3. So is that there in the option? Yes, more than v root 3. That's it. Yep. Oh, thank you. Some of you were already saying, sir, 3 by 2 mv square. Thank you. Thank you. Yep. Okay. So I hope this is clear. That's the answer. Option is more than v root 3. Yep. Great. Great. So this is how you are supposed to solve the question. It's just formula based, and remember the frequency is tripled, so just take this value, substitute it over here, and rest all is pure maths, nothing great. And this last step was important, that comparing, okay, v1 square is this plus this, it's more than this as well as this. That's it. Okay, cool. Let's get going to the next one. Is it best to read topics or do more sums and PYQs? Kirtana and every other person out there, remember one thing. It's not a good time to actually sit and read the theory and actually study a new chapter. If you are studying a new chapter, you are doing a wrong thing. Okay, you cannot do that now. Okay, the anode voltage of a photocell is kept fixed. The wavelength of the light falling on the cathode is gradually changed. The plate current versus of that cell will vary as follows. Which of the graph is the correct one? Some of them are previous year, some of them are new ones. Let's see how many of you can do this, figure this out. So the anode voltage of a photocell is kept fixed. The wavelength of the light is gradually changed. If the plate current is changed because of that, which is the best graph which shows this? Come on, come on, come on. Think about this. Thank you, Sundar. Thank you, Princess Lucky. All right, Abdul Pramesh saying D. Come on, my warriors. Aryan is saying B out there. Sahil saying D. Interesting. Come on, my warriors, figure this out. So, here is the logic. Let's say I increase the wavelength. Now remember, the energy of a photon is hc by lambda. So if you increase lambda, the energy of the photon will decrease, correct? So when the light falls, okay, this is the light which falls on the metallic surface, and it's said that the voltage is kept fixed, you have not changed it. So the electrons which are ejected, these kinetic energy, the kinetic energy of those electrons, think about it, this kinetic energy will decrease. Don't you see that? It will decrease. So what will happen? When wavelength is increased, photons energy decreases. If photons energy decreases, energy of those electrons which are ejected out also decreases. So very few electrons will reach on the other side. That means if electrons decreases, the current also will decrease till a point where the frequency of light reaches so low value, or the wavelength has increased so much that no electron is ejected because it has not even crossed the threshold. So that's when no electron will come out and there will be a cutoff. You can see there is a cutoff over here, and that means the correct answer will be D. There is no cutoff anywhere else, and it should continuously be decreasing. So hence the correct answer is D. Everybody, very good. Some of you are saying C, no, and some of you are also saying A, wrong. Nah, that is wrong, guys. It is D. It's not B also. Okay, cool. Yes, correct, Janvi. Now it's not the time for thinking about all of that. It's now time to study. Okay, cool. If you just do last 20 years, it's difficult. But Anurag, you need to do much more than the last 20 years. Yes, the last 20 years question papers will help you boost your percentile. So you can always boost something when your base is strong. So if your base is strong and if you work out all the examples of past 20 years, you can easily expect a rank, not rank, or rather I would say mark increase of maybe at least 20 to 30. 20 to 30 marks can easily increase just by solving the previous year questions, provided your base is strong. If you just solve those questions, it is of no use. Okay, so let's see if we can do this question. Beautiful question coming up on your screen. Ruchita, I have heard you, bacha. I'm doing a formula revision session on Sunday morning till afternoon in a beautiful way. So I hope you guys will be there. Come on, let's see if you can solve this question. There is light of intensity I and it is falling on an absorbing sphere of radius R. What is the force exerted on it? Option C for the previous one is of no use. Who am I? Because when you increase the wavelength for the previous question, understand for option C it was like this. When wavelength was increased, current was also increasing. So it is out of question. It's not going to be the correct one. It should be eliminated. When wavelength was increased, current should decrease. Understand? So that's why it was out of the way. Okay. Now, here is the thing. Do you know the formula? Do you remember the formula for radiation pressure due to a light beam of intensity I? If you remember it, it's very easy, or else you will spend the rest of your time deriving it. So you should know that formula. So radiation pressure. I am giving it to you, radiation pressure. Now what is the meaning of radiation pressure, guys? When light falls on any object, it has momentum, and that momentum is changed, so it applies some force. So that force per unit area is called as the radiation pressure. That formula is given by I by C for a perfectly absorbing material, and if it is reflecting, it is 2I by C. If it is perfectly reflecting. Is it absorbing or reflecting? It is clearly mentioned it is an absorbing material. Okay, cool. Next up, this is a sphere. The light rays will be going like this. Some of them will get blocked, some of them will not get blocked. How much area will get blocked? Think about it. What's the area of light which will get blocked? Is this area. What is this area, guys? This area is just pi r square. Think about it. If a sphere is kept on the way, it's not 4 pi r square. Think about the projected area. Projected area. So when I talk about the force will be the pressure multiplied by the area. Now what's the pressure? Because it's absorbing, it is I by C. What's the area? It is pi r square. So it is I pi r square by C. That's the answer, final, nothing else. A lot of people write 4 pi r square. Or some people are geniuses. They say, sir, only this part is exposed, so it's half the sphere. Sir, that was the trick. And then they write 2 pi r square. All of them are wrong. Be careful. Yes, that's how it is. Okay, cool. So in 0 to hero, I have already done one shot on optics. God, Bhagwan. So it's done. So you can watch the replay. I've already done one shot on optics. Okay, so that's the answer. Beautiful. What a beautiful question. Yeah. So if it was reflecting, remember 2I by C. If it is absorbing, I by C. Okay, keep that in mind. And this is pressure formula. Remember it. A lot of questions have been asked many times on this. All right, Gokul, come on, let's get going to the next one coming up on your screen. But before that, electromagnetic waves. So these were some amazing questions on photoelectric effect. Now we are going to slowly move to EM waves. A lot of people skip this topic, but you'll be surprised to see in the last few years, I don't know, NTA has been giving a lot of questions, at least one question. They won't give two questions obviously. One question on EM waves. And it is very simple, it's scoring. If you know it, if you know the theory, the concept, the formula, that's it, you can get it. So in fact, I have made a one-shot video on EM waves. If you just search EM waves Shreyas Sir, you will get it. In the first 2-3 results only you will get it. I'm pretty sure a lot of teachers have conducted EM waves, but Shreyas Sir is only one. So if you just search EM waves Shreyas Sir, you will get it. If you search any topic, optics Shreyas Sir on Google or on YouTube, you will get it. You search anything, whatever, semiconductors Shreyas Sir, you will get first 2-3 results, because semiconductors are many, but Shreyas Sir is only one. Okay, let's get going to EM waves question. Are you guys ready? All my lovely warriors out there on JEE Enthuse as well as Catalysis. Good evening, Gaming with Samurai. Yep, let's get going. Glad to know that, Ruchita. All right, EM wave is super easy, but I have kept some tricky questions. There is an electromagnetic wave in vacuum. It has some electric and magnetic field, which are always perpendicular to each other. Obviously, you just saw that electric field and magnetic field are always perpendicular to each other. The question is, if the direction of polarization is given by x bar, it's a vector, direction of polarization, and that of the wave propagation is given by k bar, this is not k hat, this is k bar, some vector, then which vector is parallel to which vector? That's the question. That's the question. Thank you, Princess Lucky, Prithvi, Yalni, Yo Tornado. Yes, Anantula. Yes, Rockstar Raghav. Come on, let's get going. Thank you, Rakesh. Thank you, Sai. Thank you, Maheshwaram. Come on, my warriors. Think. Very, very beautiful question. Conceptual. Glad to know that, Anmol Krish. Even today's session is going to be amazing. All brilliant questions. Modern physics as such is easier than mechanics. So these are the level of questions for mains from modern physics. Let's see how many of you can get it. Some of you are saying B, some of you are saying C. Let's figure this out. Beautiful question, guys. Okay, come on. Last 5-10 seconds before you lock your answers, and then we'll go ahead. So guys, where is it? Yeah. Electric field and magnetic field are given. So the direction of the wave propagation is given by k hat. Now you should know this. Electric field vector cross the magnetic field vector is always parallel to the velocity of the light. Now the velocity of the light and wave propagation is the same thing, so that should be parallel to k bar. So E cross B, not B cross E, E cross B is parallel to wave velocity, light velocity. So here light velocity is nothing but k bar. Okay, next, this is just pure theory. Direction of polarization is the same as the direction of the electric field. It's the same thing. So when you have electric field and when you have magnetic field, if this is magnetic field and if you have electric field, the plane of polarization is the plane in which the electric field is. So X is parallel to E and K is parallel to E cross B. That means option B is correct. Many of you were wrong out there. Many of you are saying C. Be careful. Magnetic field and X are not in the same direction. Electric field and the plane of polarization are the same thing. Okay. So be careful with that. So the direction of polarization is electric field. E cross B is wave velocity. Cool. Let's get going to the next one. I hope you are learning a lot of new things. Imagine these kind of questions came in the exam and you made a blunder, and then you would have thought, oh, I should have just attended that class from Shreyas Sir. I would have probably wasted, I don't know, you might call it wasted or utilized 3 hours, but I would have at least got that one question correct. In the exam, one question correct means plus 5 marks. Why plus 5 marks? Because if you make a mistake, you will get -1. So -1 and +4, that's the difference of 5 marks. Okay, let's get going to the next one. During the propagation of electromagnetic waves in a medium, only one of them is correct. Let's see how many of you can do this. Yes, thank you, Joshua. All right, Janardhan saying A. Come on, my warriors. Is this PYQ? Some of them are PYQ, some of them are not. So it doesn't matter. Just keep solving. Bacha. Don't think about whether it is PYQ or not PYQ. That's none of our concern. Okay. So which of them? Electrical energy density and magnetic energy density. You should know this by theory. Energy density of electric field and magnetic field. You should know it by heart, guys. I mean, yep. So remember one thing. When you have electric field and magnetic field, the energy in E and B per unit volume is same. So I think this is the one, option C, and this is also equal to half of the total energy density. So because remember, there will be electric field, magnetic field. Both of them will carry energies. Each of them will be equal, but there will be half of total, because electric field energy plus magnetic field energy will be total energy. That's it. Simple. And in case you have forgotten, energy density formula, rho for electric field was half epsilon naught E square. Energy density for magnetic field is given by half B square by mu naught. This was the formula. Do not forget. Keep this in mind. Okay. Chalo, let's get going to the next one. I think C is correct. Beautiful. Excellento. Yay. A lot of you are saying theirs is correct. Yes, this was quite natural. Now this is very tricky. A lot of you are going to make mistakes. Let's see how many of you can get it properly. Come on, my warriors. Let's see how many of you can do this. Electric field and magnetic field are given, and the direction in which it is going is Z direction. That means K hat. Only one of them is correct. Let's see how many of you can get it. Very good, Janardhan. When will they become zero? They will become zero obviously when either electric field or magnetic field is zero. There is no wave, obviously. Come on. So marks for 90 percentile is Vedantu's rank booster series and mock test series is enough. So Jupudi, I would say apart from rank booster and mock test series, please take up the test series which is there for 800 bucks in the description box. Take that up. There are 20 mock tests with discussions. So please give that also, because once you do that, I can tell you that yes, that's a good amount of preparation. That's like a safe preparation for those percentiles. Mock tests, Diksha, per day you should give 1 to 2 mock tests right now in this point of time. You should not be studying chapters. Okay, many of you are wrong. Many of you are wrong, I feel. A lot of you are saying A, some of you are saying C. Interestingo. First of all, I just told you electric field is perpendicular to magnetic field. That's how it is, right? If one is electric field, the other one is magnetic field, they both are perpendicular to each other. Cool. So the dot product E vector dot B vector should be 0. Now try to do the dot product for this, this, this and this. Obviously all the terms are positive. When you do the dot product for this guy, it is obviously not 0. Okay, the first one, 2 into 1 and 3 into 2, obviously it's not 0. For this one, minus 2 into 3, it's minus 6, minus 3 into minus 2 plus 6, yes, the dot product is 0. Okay, for this guy, 3 into 4, 12, 4 into 3, minus 12 because of that minus sign, so they will cancel out, so hence the dot product is 0. Okay, cool. For this one, 1 into 2 and minus 1 minus plus, okay, so obviously this will not be 0. So obviously A and D are eliminated. A and D are eliminated. Everybody understood? B and D, no. See guys, 1 into 2 and minus 2 into minus 1, that's plus 2. So both of them will add. So obviously it is not 0. The dot product is not 0. B or C. Now how do we choose between them? So for that, use this concept. Electric field cross magnetic field should be parallel to speed of light. Now let's do this. Speed of light is in z direction, that means k hat. So think, what will this cross this give you? This cross this, because only these two are the options. So I cross I is 0, j cross j 0, I cross j, in case you have forgotten, remember this rule, I j k, it's positive this way, alright, and it is negative this way. Use that. Minus 2 cross minus 2j, minus minus plus I cross j is k, 2 into 2 4. So this will give me 4 k cap. Check this out. And 3 3s are 9 and j cross I. So j cross I is minus k, but that was minus j, so it will again become plus. So plus, yep, so it is going to become, yeah, I hope 9 k cap, yep. So this will become 13 k cap. Do you see you are getting k cap over here? That means B has to be the answer. B has to be the answer. If you do the calculation for this, okay, you are going to get something negative. You can try it out if you do not believe me. 3 into 3, 9. I into j is k, but that was minus j, so it will be minus k. So it will be minus k cap, and 3 3s are 9, so minus 9 k cap, and 4 into 4 16, so, and that is j into I is again minus k, so it's minus 16 k cap. So you can see this is minus 25 k cap. Obviously this is not the answer. So the logic over here is two things. Number one, electric field and magnetic field are perpendicular. So using the knowledge of vectors, the dot product should be 0. So I took out the dot product because it's very easy for all the options. I saw the first and the last option, the dot product is not 0. So it's 0 only for B and C. That means electric and magnetic field are perpendicular to each other. Okay, done. Checklist, okay. Next thing which it should satisfy is electric field cross magnetic field should be parallel to the velocity of the light. So speed of light is in the direction of z, which is k hat. So do the cross product of these two, do the cross product of these two. This gives you k cap, this gives you minus k cap. So obviously this is wrong, this is correct. That's what we have done. Okay, very good, all my warriors. Yes, B. Abdul Shaikh, you just need to probably touch up on whatever you know above average. Do not do something new, and just make whatever things you know stronger, and give a lot of mock tests and just practice a lot of questions. That's what I would say. Yeah. Will I get before missed classes in crash course if I take it today? Yes, Sharan. Whatever classes you have missed, even if you take it today, you will get all the recordings of all the missed classes. Even if you have missed the test, you can watch the recordings and you can still give the test by putting up a timer, and you will get a detailed analysis. So don't worry, even if you take the crash course now, you can still watch it. Still there is time, because the fourth attempt is still almost like 10 to 12 days away. Okay. So guys, do you want me to come here? Do you want me to take more mock tests? So go hit the like button if you are loving this session, if you have not done it already. Here is the next question coming up on your screen. I am very good, Vijay Kumar, and I don't know why you are not active, but please come over here. I would love to have all my lovely warriors studying under me. The only joy I get, is when I come over here and I actually teach. Trust me, I do not like just sleeping and just lying idle. For me, the whole intention of my life is to come and teach. That's it. That's my intention. Harshit, probably we will take it offline, bacha, because you are in 11th standard. Probably we'll have a separate session, or just leave a comment or ping me on my Instagram handle. I'll definitely help you out. Okay, thank you Harish, thank you Rockstar, thank you Ruchita. Okay, what about this beautiful question, theory based? Let's see if you can get it. Right hand thumb rule, yes Tanishq, you can go a right hand thumb rule, but that method of IJK is very simple. IJK clockwise is positive, and if you go anti-clockwise, it's negative. It becomes very simple. Okay, come on. Glad to know that, Ratnam. Okay. Chalo, let's get going. So there is an electromagnetic wave of this frequency. Dielectric constant is also given. Now the speed of the light in any medium is given by 1 by mu naught epsilon naught, because there is dielectric constant, so I'll put K. since it is given that the dielectric constant is actually 4, so I'll just separate it out like this. This term over here, 1 by root mu naught epsilon naught, is just speed of light in air, nothing else. So what did I get? I got speed of light in the medium is speed of light in air, and root of 4 is 2. Okay, so speed of light will become half. What about the frequency? Frequency is always constant, do not forget it. And speed of light is frequency into wavelength. Frequency into wavelength is speed. Okay, so this will be again same frequency into wavelength in air, and this thing divided by 2, ff goes. So lambda inside the medium will be lambda of air divided by 2. So which option is matching? Wavelength is halved inside the medium and the frequency remains unchanged. Is it not option A, guys? How many of you said A? Beautiful. Thank you, Apeksha. Glad to know that. Very good, very good. My lovely warriors have got it. Excellent. I'm really happy to see that. Yes, the answer is A. Beautiful. Let's get going to the next one. Let's see how many of you can actually do this. It's a beautiful question. Beautiful question. Okay, come on. The magnetic field in a plane electromagnetic wave is given by magnetic field. This is wave equation. It's in J cap. This T is Tesla. Don't get confused by so many symbols. It's B naught. B naught is the amplitude. Kx plus omega t. Try to remember 11th standard waves chapter. Any wave equation is A sine kx plus or minus omega t. Okay. J is the direction. T is Tesla. That's the unit. Expression for the corresponding electric field will be which one? Think about it. For 85 percentile and above, Jupudi Ratnam, it should be very low, man. I mean, like, see, you should probably get 120 or something. Yeah, it's very low, 120 or something. Oh my God, Ankit is having gulab jamun these days. Luxury, bliss. Okay, C, B. Interesting. Let's see. Now, there is one equation for electric field and magnetic field. Electric field by magnetic field is always C. Okay, keep this in mind. Electric field by magnetic field is always C. Okay, so electric field will be magnetic field equation multiplied by C. So it will be B naught C sine kx plus omega t. Cool. Now, which are the options which will get eliminated? Obviously, there is a minus here. So that means this option is wrong. Then this is fine. This is wrong because of this B naught by C. So this option is also wrong. Now, either it is this or it is this. So whether it is minus outside or there is no minus outside, that's something we need to figure out. Let's do this. Now, how do you decide between A and C? How do you do that? Well, do not forget, I just told you, electric field cross magnetic field is always parallel to velocity of light. Think carefully, if there was a question in this, where is the light wave moving? In which direction? I cap, minus I cap, J cap, minus J cap, K cap or minus K cap. What is your answer? Let's see how many of you get this correct. SRM is okay. It's a good local university, but on a national level, it's not a great university, tech world. Okay. So, what do you think is the correct answer? Which direction is the actually wave moving? In I cap, minus I cap, plus J cap, minus J cap, plus K cap or minus K cap? Yes, it's going, look at this term, this is X. Whenever you have an equation in X, it's obviously going in the X axis. Now, if this is plus, if it is plus, it's going in the negative direction. And if it is minus, it's going in the positive direction. That's how it works. So right now, this wave is actually going in the negative X direction. Keep this in mind. It's going in the negative X direction. That means, understand this speed of light is minus K cap. Okay, speed of, oh sorry, my bad, minus I cap. This is minus I cap. Okay. Electric field cross magnetic field. Magnetic field is in J cap. Okay, this is J cap. Now think, what should come over here? What should come over here so that that cross J will give you minus I? That cross J will give you minus I. Think carefully. If you do not get this even now, well, I will draw this circle for you. I, J, K. You want minus I. Minus I means you need to go like this. This is negative, so that you will get minus I. What cross J will give you minus I? Isn't it obvious? This should be K cap. Hence, the correct answer is option A. Understood? This is a logical way of doing it. You cannot just mark, sir, I think it is A, sir, minus sign won't be there. No, it could have been minus. It depends. It depends, guys. I mean, you need to solve it logically. This is the method of solving these questions. Very good. Excellent. So if you guys are loving these sessions, please guys show me your love and support. And yeah, I'm there for you. I'm going to be there on Thursday. I'm going to make some special announcements in the coffee with Shreyas session. Friday morning again for, electromagnetism, and then Saturday mock tests and so many other things, and formula revision on Sunday. Monday again sure shot, and obviously after that mock test discussions. Now it's time for a small break. How about this time for a small break, 10-15 minutes, and then we'll return for the remaining part. So we are going to start with atomic structure, X-rays and nuclear physics. Okay, so are you guys ready for a small break? Because it's going to be a long session. My throat also needs some break. You also quickly freshen up, don't leave, because it's a long session, guys. Semiconductors will also be done, and even communication systems will be done. Electronic devices will also be done. Okay, chalo, let's take a small break. I'm just going to put up a timer out here. Okay, so hold on, guys. So let me just put up a timer out here for 15 minutes, not more than that. Okay, cool. We will return back shortly. Hello everyone, welcome back. Can you guys hear me loud and clear? Can you guys see me properly? Do let me know in the chat box. So how was your break? Welcome back. Tanishk, it's very difficult. No, I mean, it's near to impossible to get into NIT with 86 percentile. Yes, Swati is coming. Rather, Swati has come. Okay. Hello, Rejoice. Hello, Yazir. Welcome, Ankit. And Ankit is still fantasizing all the sweets. I'm pretty sure, Ankit, you're going to become very fat very soon with all these sweet words. All right. So during this time, should we revise or give mock tests? Both. Arshita, you should revise the formulas, revise the theorems, revise the laws, and also the mock test. In fact, how you should do is solve the mock test. From that, you will understand which are your weak points, pain areas, and accordingly do the strategic revision. Okay, let's get going. Cool. So let's get going. And yeah, sort of you're back. Okay, so let's get going, guys. So next chapter is atomic structure. So remember, in atomic structure, the main things are, you should know the Bohr's postulates. Those postulates like, you know, the nucleus is very small, the electrons go around it in circular orbits, energy is absorbed during higher transition, and during the lower transition, energy is released in the form of photons, and the angular momentum is always nh by 2 pi. You should know the graph, or rather the relationship of energy with n or z, velocity with z or n, and also the radius of the Bohr's orbit. You should know. Don't remember the formula, just remember whether it is proportional or inversely proportional. You should know that. And you should also know when a photon is absorbed or released, what is the wavelength formula. So with the Rydberg's constant, 1 by lambda is Rydberg constant, z square, 1 by n1 square minus n2 square. So all of these are very important points. So just to give you a quick roundup or brushing up of that particular topic. So here's the first question coming up on your screen. Thank you, Vamshi. Welcome aboard. Hello, Google. Come on, join in, bacha. So there we go. So the wavelengths involved in the spectrum of deuterium are slightly different from that of hydrogen spectrum, because this is proper theory conceptual question which was asked in 2014. Start Panunga. Yeah, it's already done. Yes, sir. Hello, Gokul. Welcome. Come on. Okay. See. Let's see how many of you can get it. The size of the two nuclei are different. Come on, my warriors. Show some energy. Show all your josh. Don't be afraid of giving a wrong answer, because you have come here to learn. Okay. Ritesh saying A. Ruchita also saying A. Interesting. The wavelengths involved in the spectrum of deuterium and hydrogen are slightly different. Size are different, nuclei. Nuclear forces are different. Masses of the two nuclei are different. Attraction between electron and the nucleus is different in both the cases. See, guys, when you derive that formula for energy, radius, velocity, etc., the derivation proceeds for energy with, you know, the electron revolves in a circular orbit, and there is a force of electrostatic between the nucleus and the electron. When I say nuclear forces, this nuclear force is between proton-proton or proton-neutron or neutron-neutron, not between proton and electron. So the nuclear forces are different is obviously wrong. The masses of the two nuclei or the size. How does size play a role? Size has nothing to do with the force. A nucleus might be small or big, as long as the charge or the mass inside is same, you know, it will not make any difference. So the size has no relevance. Only the mass or the charge plays an important role, not the size. Keep that in mind. The masses are different. Yes, in fact, like I said, the mass and the charge plays a role. So for a deuterium, obviously you have that extra neutron. So that plays a big role, and that's why the forces could be different. You know, everything else will change. The constants will change slightly, and the attraction between the electron and the nucleus is different in the two cases. So this is not correct. This is correct. The attraction is not the concern. Because of that heavy mass, small changes are going to definitely happen over there. So that's why you're going to see the correct answer is C. Yep, it's not D, guys, it's C. Thank you for all the love. Okay, hello, welcome Rushikesh. Oh, Janvi, you got the wrong answer, I guess. All right, yep, come on. So the admit cards should have been released, guys, or probably it will release in a day or two. Don't worry about it. Okay, let's see the next question. Hydrogen is there, deuterium is there, singly ionized helium is there, doubly ionized lithium is there. All of them have one electron around the nucleus. Okay, now consider an electron transition from 2 to 1. So from higher orbit to lower orbit. Some wavelength will be emitted. Lambda 1, lambda 2, lambda 3 and lambda 4. Then which is the approximate relationship between all those wavelengths? Assume atomic structure or assume Bohr's model is correct. If you guys have joined in late, no problem. You would have missed the initial part. You can watch it later on after the session ends. The entire replay will be available. Don't worry about it. Sai, don't chill so much with your spine. Just keep your head cool. Let your head chill. I mean, the reason why you're attending this mock test is so that you know what is your weak point. It's not a difficult thing to just quickly brush up through all these topics later on. Just note down which are your weak points in everything. So I hope you have a notebook beside you and a pen for not just you, for everyone out there. Hello Rushikesh, welcome aboard. C and D, people are getting confused. Come on, think carefully. You should know the formula. If you know the formula, you'll get it. If you don't know the formula, then again you will be stuck. Okay, let's see how to do this. First of all, the formula is 1 by lambda is equal to Rz square into 1 by n1 square minus 1 by n2 square. Now n1 is same, n2 is same, R is also same. Only thing which is different is Z. That's why lambda is different. So clearly lambda is inversely proportional to 1 by Z square, because they both are, on the opposite sides. This is denominator, that's numerator. So lambda is inversely proportional to 1 by Z square. So hence lambda 1 is 2, lambda 2 is 2, lambda 3 is 2, lambda 4 will be equal to, think about it, 1 by lambda square, 1 by Z square. So the first term will have 1 by 1 square because Z is 1, correct? The next term, deuterium, deuterium also has Z is equal to 1. Don't take A, you have to take Z. This is Z, that's A. So this formula, that Z is the lower thing, not the upper thing. So this is also 1 square is 2. Third one, it has 1 by 2 square. Fourth one, it has 3. So 1 by 3 square. So that will give me 1 is to 1 is to 1 by 4 is to 1 by 9. So which is the correct answer? Yes, it is C, guys. I mean, look at it. Lambda 1 and lambda 4. Just look at the extreme ends. Lambda 1 and lambda 4. Lambda 1 is 9 times higher than lambda 4. 9 times, because lambda 4 is 1/9 of lambda 1. So lambda 1 is 9 times of lambda 4. So you can see lambda 1 is 9 times of lambda 4. So that's the reason why option C is correct. I mean, you can check it out for everything else also. Lambda 1 and lambda 2 are equal. 1 is to 1. You can see the ratio is 1 is to 1. So lambda 1 and lambda 2 are equal. Yes, that's how you do it. Okay. No need to check others, but it is obvious now. Okay, cool. That's the answer, guys. Thank you, Princess Lucky. Glad that you guys are loving it. Thank you guys for all the support and love you give us. Okay, let's get going. And here we come with the next question. Formula based, conceptual based, and you need to think about proportionalities. If there is an electron and it makes a transition from excited state to the ground state in an atom like hydrogen, then which of the following is correct? Only one is correct. Kinetic energy will decrease or increase, potential energy will increase or decrease, total energy will increase or decrease. Don't look at the option, solve it. Think what will happen to kinetic, what will happen to potential, what will happen to total, and then look at the option. If you look at the options first, you're bound to get confused. So think about it. Okay, Shifa is already saying A. Sai, Karthik, they all have one electron because they are ionized. Remember, the word used was ionized. So you have taken out all the electrons. That's the reason why there was only one electron. If multiple electrons are there, then Bohr's model is not valid. That's the problem. Okay. Mudit saying C, Rejoice saying C. Okay. Abhiram saying D. Ritesh saying B. Come on. Think carefully. What do you think will happen, guys? Figure this out. I'm giving you some time to think about this. Some of you might take a little bit more time than usual because it's slightly tricky. Okay, let's figure this out. So, what you need to do? First of all, you need to know the formulas correctly. What are the formulas? Energy is directly proportional to Z square by N square, but there is a negative sign. I hope you remember that. This is the total energy. Now, if you go from excited to ground, be careful, N will decrease. Because you are going from excited, higher value of N to lower value. So the denominator will decrease. That means this entire term will increase. But there is a negative sign. So it will become more negative. If it becomes more negative, that means this energy should decrease. Keep this in mind. Yes, that energy should decrease. Now, I hope you remember one more formula. The potential energy is nothing but twice of the energy itself. That's the standard formula. Potential energy is twice of total energy, or total energy is P by 2. That means if energy decreases, potential energy should also decrease. Cool. Now the last thing for kinetic energy. Kinetic energy is directly proportional to V square. But V is directly proportional to Z by N. So that means it is proportional to Z by N whole square, because V is directly proportional to Z by N. Now you just think N has decreased. So this whole term has increased. That means kinetic energy also has increased. So kinetic energy has increased. Yep. So look at that. Kinetic energy has increased, and other things. Where is kinetic energy increased? Yes, kinetic energy has increased, and potential energy and total energy has decreased. Yes, check this out. Option C. Option C should be correct. Understood? So if you know the formulas, you will get it. So how many of you remember these formulas? How many of you remember these formulas? If you don't remember these formulas, gone. So that's why I said when I started atomic structure, you should know who is proportional to whom. Velocity. If you do not know what to remember, I'm giving you, write it down. Velocity is proportional to what? Z by N. Okay. Radius is proportional to what? It's proportional to N square. And energy is proportional to negative Z square by N square. You should know these things. Only then you can get it. And yes, obviously that relationship, that total energy is potential plus kinetic, and potential is equal to twice of total, and kinetic is negative half of total, and all of that. Standard things. You should know that. Okay. I've solved a lot of questions. I cannot count, Joshua, but you can watch the replay later on in case you have missed it. Yes, Tanushri, you are quite late. Oh my God, you slept off. It's not the time to sleep. You have to stay awake. Okay. Very good. Chinu knows it. Yalini knows it. Vishwa also knows it. Okay. Priyanka, fine. Now onwards, you remember it. Okay. Rejoice, I hope it's not buffering now. Okay. Janvi is saying C now again. Yep. Let's do this. But remember it with the sign, Pramesh. Yeah. Very good. Okay. You have put it with the sign. I can see that. So there is an electron attracted towards the origin with a force of k by r, where k is some constant, r is the radius or distance from the origin. Now if you apply Bohr's model to this kind of a system, the radius of the nth orbit, this is going to be a difficult question, I'm warning you in advance, and the kinetic energy will be, let's say, Tn, then which of the following is true regarding the proportionality? Very good, Ritesh, you're full on energy. Very good. Chalo. Thank you guys. When you say such things, even I get energy, and I will, that's what happens. I transfer that energy to all the other students who are probably low on energy. Right. Now, the way to go ahead with this is, it's clearly mentioned that the force is K by R, and this force will be the centripetal force, and the centripetal force will give rise to mass into centripetal acceleration. So how about writing this? K by R is equal to mv square by R. Reason why I'm doing? Because I want to figure out who is proportional to whom. You cannot use your old proportionalities. Why? Because electrostatic force was inversely proportional to R square. So Coulomb's law is not valid in this question. So don't be smart or don't be dumb to use whatever I had told just some time back and solve the question. That is not going to give you the correct answer. That's why I said read it. A lot of you are saying A. That's wrong, guys. Please understand this. I can see that so many of you are saying A. That's wrong. You might be like, sir, just now you told, sir, radius is proportional to n square. Guys, that's only true when Coulomb's law is valid. Is this Coulomb's law? It's some weird law. For this new force, what's the new answer? That's the question. Okay. Let's see. How do we do that? Mudit, if you have a doubt, you can leave it after the session ends. I'll reply to that comment in YouTube comments. Okay, don't worry. Not in the live chat maybe. Okay, so RR will get cancelled. So K, this is not kinetic energy, this is some constant K, okay, is just mv square. Now K is a constant, m is a constant, so V is also a constant. Now speed is a constant, the kinetic energy is clearly mentioned. The kinetic energy is Tn. So Tn, Tamil Nadu, is half mv square. But V is constant, M is constant, half is constant. So that will be also a constant value, Tn. Now if Tn is constant, obviously A is wrong, C is wrong, D is wrong, B has to be correct. It's independent of the value of M. Yep. Now, if you want, you can solve this, but it's not needed in the exam. But still, if you want to solve this, you can solve. Is radius proportional to N? Yes. How do we get that? Yeah. L is nh by 2 pi. So angular momentum is nh by 2 pi. That's Bohr's model. So angular momentum is mvr is equal to nh by 2 pi. So the radius is equal to nh by 2 pi mv. All these terms are constants. It's clearly V is a constant. So all these terms are constants. So R is directly proportional to N. So that's also correct. Got it? Oh my god. Somebody is saying already -1. Rockstar Raghav, what happened, man? Got it or no? Okay. Cool. Yes, Nupur. Yes, Joshua. The answer is B. Okay. So who am I? You can watch the replay bacha again, or you can just take the slider behind and watch it in repeat mode. It's very simple. Okay. That's the advantage of YouTube. Okay, so the idea is you cannot use your regular formulas. Is that idea understood? Did you understand the concept in this question? You cannot use your regular formulas. Why you cannot use? Did you understand that? Because this force is K by R, and that's why you need to go by the basics. So some people ask, sir, is derivation important, sir? Yes, derivation is important. Do you understand the importance of derivation? For these difficult, that 15% difficult, remember I have told you that 15% of the questions are difficult in JEE Mains, roughly this is. So for those questions you will need it. They have changed the assumption, and then you need to know the derivation. How do you find radius? How do you find kinetic energy? How do you find velocity? If you know that, I'm not saying by heart the derivation. If you know it, then it will click. Yes, that's why derivations were very important. In case you have not read any of the derivations, then don't do it right now. Just brush up on other things. Yeah. So Nagasamy, the reason why you did not get any ideas, probably you have not studied the derivations. Okay. So that's how it is. Okay. Come on. Let's get going to the next one. Yep. Come on, my warriors. If 36 electron volt energy is required to ionize a Bohr-like atom, 36 electron volt to ionize a Bohr-like atom, then, not then the energy required to remove an electron from the second orbit is, come on, think about it. And yeah, that's a perfect thing, music stories, what you told to Nagamani. See, Nagamani, in fact, just few days back, right, I gave a strategy. In fact, I gave 4 strategies plus pointers plus some star method, some thumbs down rule and all of that. So all of this was given. Please watch that strategy session. That will help you improve your percentile, and it will help you analyze what to do if you do not know a question, the solution of it. So let's see how many of you can do this. So assume that Bohr's model is valid. Then is saying, when I said derivations are important, you sounded like Beshwa Kalyan Rath. Oh, is it? I take it as an honor. Okay. Okay. Come on, my warriors, think about it. Okay. Always, Saurav, I'm always there for you. Okay, let's do this. A lot of you are saying D and A. Confused between D and A? Interesting, interesting, interesting. So, do you remember? Now the original formula is valid. I just told you that formula. E is something constant, okay, some constant with negative sign by, okay, n square. This is what I had told you. This is the energy. Now the ionization energy is exactly opposite in sign but same in magnitude of the energy of the electron. So magnitude wise it is same, that negative sign will not come. So it will be constant divided by n square. That's the formula. So now you think over here, it was 36 for a normal atom, okay, to ionize it. So that means 36 was constant divided by 1 square. For some other atom, what is the energy, which I don't know. So if you divide it, think about it, you will get C by n is 2. Think about it. Yes, for n is equal to 2, to take it out from the second orbit. So just divide them. Did you understand what I just did? Oh my God, lot of you are wrong, guys. Lot of you are wrong. So what are you going to get? 36 by E is equal to 4. So E is 36 by 4, which is 9 electron volt. Answer is D. Be careful. A, all those people saying A, I can see Rejoice Palla and Ritesh, so many of you said A. No, be careful. It is not 3.6. I don't know how you got that. It's not correct. Okay, the answer is 9 electron volt. Be careful. So the idea was that the energy is inversely proportional to n square. So if n becomes twice, n square will become 4 times, but it is in the denominator. So if n square becomes 4 times in the denominator, that energy will become 4 times less. So hence the answer was 36 by 4, which is 9. Ritesh, now did you understand, bacha? I just explained it. So you should know. So remember, what is this ionization energy? In case you forgot, see, when you have this nucleus and these electrons are there, each electron might have some energy. What's the energy of an electron? Let's say it is minus 36, okay, minus 36 electron volt. So if I want to take it till infinity, how much energy do I need to give? This is the ionization energy. The ionization energy is energy required to knock it out till infinity. That will be plus 36 electron volt. And this energy was inversely proportional to n square. That's all I have used. Okay, understood? No, it is not 13.6. A lot of people make that mistake. I knew it. That's why you would have said 3.6. So examiners will exactly make use of this, loophole or this silly mistake. They know you guys are looking at this 36 as 13.6. You guys are thinking, sir, that one was missing, that decimal is missing. And then you would have got probably something else. Be careful. Yes. Can we use that formula? Who am I? Exactly. Isn't it the same thing? Is it necessary, who am I, to actually write down that formula z square 13.6 and by n square? No, I know all these things are constants. So forget it. So just write it as 1 by n square or just put constant by n square. Isn't it? So why do you want to worry about those constants? Don't worry about those constants. Okay, let's get going. Chalo, let's see the next question. For which of the following transitions in the hydrogen atoms the photons which are emitted are of the highest frequency? Sir, 36 is how? Rajesh Saab, it was mentioned in the previous question. I don't know whether you guys didn't see it or what. What is this number 36? How 36? It was given. Okay, so if minus 36 was the actual energy, to take it to 0, how much energy you need to give? Plus 36. Because at infinity the energy is 0. Keep this in mind. Yeah. Instead of color blindness, this is number blindness. Okay, cool. Yes, cool. Chalo, let's get going. I hope Rajesh Sahib and all you have understood the previous one. Okay. Still, if you did not understand, please watch the replay again. Cool. Which of the following will give you the highest energy? Mudit is saying D, Prarthana saying D, Ashi saying A, Prashant saying C, Priyanka also saying C. People are saying A. Every option is correct now. Interesting. Come on. Figure this out. Let's see how many of you can do this. Oh, thank you, Ritesh. Glad you understood it. Okay. So for solving this question, you don't need to apply any formula. You should just know this energy level diagram. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This on the vertical axis is energy. First of all, emit photon. From 1 to 2, how can you emit photon? It will absorb photon. So this will not emit, this will absorb the photon. So this is wrong. From 2 to 6 also, it will absorb the photon. Obviously this is wrong. Guys, think na, emit photon. Now 6 to 2 or 2 to 1? Think about it. 6 to 2, okay, 6 to 2, okay, this is 6 to 2 or 2 to 1. Guys, remember this gap is much more than this gap because the spacing of the lines decreases. Yeah, this is a large spacing and this is much smaller. So this is much smaller than this. So actually speaking, this is more, option D, not C. People think, sir, 6, 5, 4, 3, 2, 1. Sir, 6 to 2, such a big gap. Sir, 2 to 1, small gap, sir. So that's why energy will be less. No, the spacing between these lines is small. That's where the IIT brains will trick you. The NTA people are going to trick you into thinking 6 and 2 is a big difference. And many of them are going to mark C. TV Subbarao is asking, what is modern physics? Very interesting question. Okay. I'll definitely conduct a lecture on what is modern physics. For sure. Yeah. What is modern physics? Okay. I'm pretty sure TV Subbarao, you are going to nail it, man. You're going to nail it. This JEE Mains, you are going to, yeah, like ace it. Very good. Okay, cool. Okay. Chalo, let's get going to the next one. Coming up on your screen. Are you guys ready? Okay. Very good. Sai Karthik, if you told D. Hello Nikita, welcome aboard. Let's see this question. In a Bohr's model of an electron moves in circular orbit around a proton. Okay. Consider the orbit of the electron to be circular current loop, the magnetic moment of the hydrogen atom when the electron is in the excited state. Come on, my warriors, figure this out. Yeah, Rockstar is going to rock physics. Come on, figure this out. In the Bohr model, an electron moves in a circular orbit. Find out the magnetic moment. How do you find magnetic moment? Is there some relationship? And how do you relate it to atomic structure? How are these two topics related? Manisha Rani, don't worry Rani, even if you are late, you can watch the replay. Yeah, don't worry. Okay, chalo. Hi Tanveer. I think this one, I don't know this one, says Tanishk. Jagdish, I'm much better. Yeah, my health was fine, only my throat was bad. Okay. Good ones, guys. You guys are cracking amazing jokes. But now let's get back to the session. Okay, I'll tell you what. See, first of all, I need magnetic moment. I had given you one formula in electromagnetism. Magnetic moment by angular momentum is charged by 2 times of mass. I have given you this formula. If you have forgotten, now this is a reminder. Just move it around. M is L into E by 2m. Now, why is it in modern physics, atomic structure? Because angular momentum, Bohr's postulate. Did I not just tell you when I started the class that you should know those Bohr's postulates? And one of them is angular momentum is nh by 2 pi. Just substitute nh by 2 pi, E by 2m. Yes, that's it. Where is it? Oh my god, such a beautiful answer, guys. How many of you got it? Yeah, see. So, this is a very easy question, but looks difficult. So, this is a very important, takeaway. Don't go by looks. Don't go by looks. You never know what is there behind the curtain, right? So don't go by looks, guys. Very, very interesting takeaway for this question. So it's simple. E by 2m, nh by 2 by direct formula substitution. Let's go to the next one coming up on your screen. Now this is going to be crazy. Let's see. This is probably going to be done only by the top maybe 5 percentile or 3 percentile. Probably about 95 percentile students will probably attempt this and try to score more. So if you want to score high, you need to solve this question. Read this question carefully. The Bohr's, oh, there is a small printing mistake out here. This should be r cube. This is not r square, this is r cube. You'll be like, sir, how does it matter? First look at the question. It's so difficult, sir. The force is E square by 4 pi epsilon naught 1 by r square plus beta by r cube, where beta is some constant. Don't worry. For this item, the radius of the nth orbit terms of the radius is radius of the nth orbit in terms of this value. A naught is E epsilon naught h square m pi e square. Now don't worry what this constant is. Probably it will come somewhere on the way when we solve this. Okay. Tanveer is from 9th class. Bacha, this is the last few classes for all the 2021, the 12th standard students. Okay, anyways, welcome. You're free to watch. No worries. How do we solve this? Start by basics. So that's why derivations are important. You will see that. Force is mass into acceleration, centripetal. This force is given to be E square by 4 pi epsilon naught. Okay. And r square is common. And I can write it as 1 by 1 plus beta by r. So I've just taken out r square outside. That's all I have done. Is equal to mv square by r. See if everybody is fine till here. Okay. Now can we cancel out few things? Maybe yes. Yep. So one of the r's will go. That's all. And anything else will happen. Let's see. E square by 4 pi epsilon naught m into r, and that's 1 plus beta by r is equal to v square. Okay, cool. This r has got cancelled from this r, and that m has been taken downstairs. But the question is to find radius. I don't want this velocity. Can I do something about this velocity? Yes. L is nh by 2 pi. Use that. So mvr is equal to nh by 2 pi. Therefore, v is nh by 2 pi. M and r, take it below. mr. So this v square, I can just substitute it as n square h square by 4 pi square m square r square. Now velocity has been eliminated. You just saw that. So this velocity has been eliminated because I've squared it and just substituted. Okay. Now you can cancel out a lot of stuff. You will see. Okay, you are probably going to get acha, this r and one of the r over here will get cancelled. So I can take that r over there and see what do you get. You are going to get r into e square by 4 pi epsilon naught. No, 4 pi and 4 pi will also get cancelled partially, and m will also get cancelled. So I will have n square h square by Okay, this 4 pi, one of the 4 pi got cancelled, one of the m also got cancelled, and hold on, let me just put it over here. So E square, okay, and this epsilon naught also I can take it on the top, okay, and this 1 plus beta by r also I can write it. This small r I can bring it on the top, and this E square, which I don't like, I can bring it here. Okay, now look at this. Epsilon naught h square by pi m e square, that's that term. I hope you can see that. That's a naught. Can you see that? That's nothing but a naught, guys. Yeah, can you see that? That's nothing but a naught. So you just need to, I think there was a 4 also missing over there. Yep, there was a 4 missing over there. I think that's a printing mistake. Yep. Now just rearrange. There was a 4 missing over there. Okay. So what you do is basically rearrange this. So this will be r plus, okay, r plus beta is equal to nothing but a naught n square. So r will be a naught n square minus beta. Which is the answer then? It's C. Yes. That 4 also got cancelled. Oh, that 4 got cancelled then. Yep, my bad. Yeah. This 4 pi square. No, it's not 4 pi whole square. It's just 4. Yeah. So that 4 will also get cancelled. My bad. Yep. So that 4 will get cancelled. So that's why you are going to get this. Yep. Thank you. Yep. I read it as 4 pi whole square for some reason. Yep. So that's the answer, which is option C, I believe. Yeah. Or yeah, that's it. Correct. Beautiful. Yeah. So guys, this kind of question probably will play with your mind and your patience, because you will see all these crazy looking terms out here. So you just solve it. I mean, if you know the formula, you should know the derivations apart from the formula. This I could solve only because you know, or rather I know the derivation. So if you know the derivation of how the radius or how the velocity comes, then you can get it. So that's why I said derivations are important. Okay, cool. Yes. Okay, Partha, if you have just started to study, probably join the dropper batch or the long-term courses. That will be helpful. Yeah. Okay, now are you ready to go to X-rays? Yes, Monu, yes, I saw that second step. Ready to go to the X-rays part? Yeah. Hello, chemistry concept. Welcome aboard. Okay. Now let me do a quick brush up of X-rays. In X-rays, you have something called as the filament. That filament is on one side, the target material is on the other side. This is the target. Current flows through the filament. There is potential difference between both of them. There's potential difference between both of them. And because of that, the electrons which flow through the filament, they get pulled by that potential difference, and they are accelerated, they get pulled and they hit the target. And when they hit the target, there is going to be X-rays which is produced below, and there are two kinds of X-rays which are produced. One is called as the characteristic X-ray and one is called as the continuous X-ray. Both X-rays are produced simultaneously. Each one of them have different characteristics and they also depend on different things. You will learn this in due course when we solve problems. Okay, chalo, let's start doing those problems. Now there is also a basically, a cooling tube out here, because this material will get heat because of the collisions, and when these electrons hit that target material, you will see a lot of electrons get knocked out. Some of the electrons will come back. So in this process of collision, a lot of heat is generated, so it needs to be cooled on the other side. So let's have a look at the questions. Probably then you will get some hint. Good evening, Hariharan. Welcome aboard. An X-ray tube is operated at 50 kilovolt. What is the minimum wavelength which is produced? That's the question. Hello Chaitra, welcome aboard. What's the minimum wavelength which is produced? Come on. Think. This is a question based on probably continuous X-rays. Hi Bharti, welcome. Come on my warriors, think. Is this not a very easy, directly doable question. Vignesh, my throat is much better. Hello Jiva, hello Anaga, hello, welcome aboard. Partha Reddy, Partha Sarthi, just via NCRT you will probably get only 50% marks. Not more than that. Because JEE Mains is much more than NCRT. Come on my warriors, think about it. C, A, interesting. Come on, you should know the formula, continuous X-rays. Now for continuous X-rays, okay, if you remember the graph looks something like this. This is your lambda minimum. An X-ray tube is operated at 50 kilovolt. Then the minimum wavelength produced is, there's a formula, Hc by lambda minimum is the energy of that electron, and that energy of that electron is E into V. Yes, that's the formula. Somebody has already written it. Beautiful. Therefore, lambda minimum is Hc by E. Okay, lambda minimum is nothing but Hc by E, and this V will also come over here. Now this number you should know, Hc by E. What is it in Armstrong? What is it in Armstrong? And if you know that, you will get it. 12400, and this V is 50 kilovolt. So 50 into 10 to the power 3. Do this and see what do you get. Do this and see what do you get. Are you getting, look at this, I mean this is like 50,000, that's 12,400. Come on, this is like 12,400, this is 50,000. It's definitely almost like 1/4. Almost like 1/4. So that's going to be 0.25 Armstrong, as simple as that. Yeah, that's it. Okay, cool. So that's the answer. You don't have to actually sit and calculate, you can just gauge it. Yeah, let's do this. Next question coming up on your screen, and here it is. A hydrogen atom does not emit X-rays because, and a hydrogen atom does not emit X-rays because its energy levels are too close, its energy levels are too apart, it's too small in size, it has only a single electron. Which one of them is correct? Think about it. Sriram, if you want to get full marks in physics, you should be just thorough with everything. You should know all the formulas, you should know all the derivations. You should love physics, only then you can get it. Okay. TV Subarao, if you want to talk to me, just contact me on Instagram. I can definitely help you out. Okay. Chalo. Come on, my warriors. Think D. Wrong. Everybody is wrong. All those people who are saying D is wrong. That's wrong. The answer is energy levels are too close. Now, see, why is this option correct? Understand, X-rays have very high frequency, short wavelength. That means their energy is very high. And how are X-rays emitted? So if you have the nucleus, these are the orbits. The electron, okay, the electron, all right, it jumps from higher orbit to lower orbit, and that's when you get X-rays. Now, if you want high energy X-rays, high frequency, that means the gap, the energy gap should be large. Only then you can expect a large energy photon coming out of it. Now, in case of hydrogen, the energy levels are so close that the photon which is emitted is of very low energy. In fact, it is generally in the infrared or visible or ultraviolet region, not in the X-ray region. So that's the reason why option A is correct. The problem was the energy gap. Good evening, Rakesh. Welcome aboard. Harish, no, I don't think so. Nobody has got full marks in advanced. I don't think so. Okay. Come on, my warriors, figure this out. There is a beam of accelerated electrons which is hitting a target, and a continuous X-ray spectrum is emitted from the target. Which of the following wavelength is absent in the X-ray spectrum if the X-ray tube is operating at 40,000 volt. Come on, think about it. Again, I feel you should just use this formula. Which formula? Which formula are you going to use, guys? Think about it. Which formula are you going to use? Again, the same formula. Hc by lambda minimum is equal to EV. Same formula, continuous X-ray. The moment you see continuous X-ray, that's it. You have to use this. Nothing great about it. So, just use this and calculate lambda minimum. It's again a repeat of the previous kind of question. It's kind of a repeat. So, just do that. Just do that. Same thing I just told. Yep. 0.25. Oh, I think this question just got repeated if I'm not wrong. Yeah, it was almost like very similar. Anyways, so let's just go to the next question because it was just a repeat. Which of the following is wrong in context with X-rays? Which of the following is wrong in context with X-rays? Think about it. Come on, my warriors, figure this out. Something is wrong. Wavelength of characteristics decreases when atomic number increases. Cutoff wavelength of continuous depends on atomic number of target. Intensity depends on power given to the Coolidge tube. Cutoff wavelength of the continuous depends on the electrons in the X-ray tube. Figure this out. One of them is wrong. Which one of them is wrong? Yeah. Come on, my warriors, think about it. Characteristic and continuous. If you remember the theory, that's it, you will get it. See guys, characteristic depends on the target material. If you change the target, the characteristic peaks also will change. See the graph which is like this, right? These are the characteristic peaks. This one is the continuous peak. This is the characteristic peak. These characteristics only depend on the target. You change the target, they will change. So that means it will be dependent on the atomic number. Okay, so that one is correct. Cutoff wavelength depends on the atomic number. Now, this one, which is the cutoff wavelength, I just told you, Hc by lambda minimum only depends on the voltage, the potential difference, not on the target material. So it depends on the atomic number. That's wrong. That's obviously wrong. Intensity of X-rays depends on the power to the Coolidge tube. Yes. If you give more power, more filament current, more energy, then more electrons and more amount of X-rays will be emitted. That's fine. Cutoff wavelength of continuous depends on the electrons in the X-ray tube. Yes. You can see this is nothing but it depends on the electrons' kinetic energy in the X-ray tube. Hence the answer is B. Yes, Sanjay, conceptual questions are asked. Who will stop JEE Mains? Have you not seen conceptual questions in JEE Mains? Please watch or read or go through all the previous year questions. All sorts of questions are asked. Questions based on derivations, questions based on formulas, question based on fact, questions based on which is not correct, questions which are based on integer. So many different types and varieties are asked. So you should know all of them. Okay, cool. Let's get going to the next one. Now, we are done with X-rays and let's get going to nucleus. Are you guys now ready? Are you guys ready? Don't worry, Bhuvi. Yes. Senthil, don't worry, we'll keep doing something or the other for 2021 batch, even for NEET. One day, yeah. Okay, ready for nucleus? Okay, let's do. Now, what are the things which you should know in nucleus? First, you should know the basic structure of nucleus, atomic number, atomic mass number, nucleus, neutrons, and the radius of a nucleus formula, some constant into a raised to 1 by 3, and density of a nucleus is constant irrespective of the radius or the atomic number. Then what is binding energy, what is mass defect, how is binding energy related to the mass defect, the stability of a nucleus, basics of nuclear forces, and then you should know about alpha particle, beta particle and gamma rays, their characteristics. There was a beautiful difference table which I have given. It is there still in the PDF. of the previous sessions. So you can go ahead and check out the playlist. And lastly, you should know the radioactive disintegration law. Okay, dN by dt is minus lambda n, and the formulas related to it, like half-life, mean life, and what happens after all these half-lives, etc. So you should know these basic things. Let's do the question based on nucleus. You have an unstable, heavy nucleus at rest, and it breaks into two nuclei which move away with velocities in the ratio 8:27. What is the ratio of the radii of the nuclei, assuming it to be spherical? Come on, my warriors, figure this out. What should be the answer? Let's get going to nucleus. An unstable heavy nuclei breaks into two nuclei, okay, which move with velocities in the ratio 8:27. I feel this is not just based on nucleus, it's also based on some other chapter. Which other chapter? I feel momentum and collisions. Think about it. If you have a nucleus and it breaks into two smaller nucleus, so this was at rest, this is, let's say, M1, this is, let's say, M2, this is V2, this is V1. So momentum is conserved. Momentum is conserved in this explosion. Hence, M1 V1 should be numerically equal to M2 V2. Now the question is ratio of the radii. Acha, let's figure this out. But before that, V1 by V2 will be M2 by M1. Now what is mass 2 by mass 1? Mass is density into volume, because only then I can get the relationship for radius. Okay, so this will be density and this will be density. Volume is 4 by 3 pi r cube, and this will be 4 by 3 pi r1 cube. Most of the terms are going to get cancelled. Rho, 4 by 3, 4 by 3, pi. Okay, so I'm just going to get r2 by r1 whole cube. Now what do? Just think, what will be r2 by r1? R2 by r1 will be cube root of v1 by v2. Now what is v1 by v2? 8:27. So cube root of 8 by 27. This is nothing but 2 by 3. But the question is r1 by r2, remember that? So r1 by r2 will be 3 by 2, because 2 by 3 is also there. Many people will mark the answer as 2 by 3. So that's a silly mistake. So you should mark it as 3 by 2. That's the final answer. Yep, you can see that. A lot of people are saying B. Look at that. So many people said B. I just told you, no, that you will make a silly mistake. So question was R1 by R2. Be careful. You should maintain that order. You will be like, sir, where is it written? Guys, obviously you will maintain the same order, right? This was V1 by V2. When the ratio is asked, they will be obviously asking R1 by R2, not R2 by R1. Be careful about it. Yeah. Don't make that mistake. So that's the reason why I'm solving these questions, because many of you will make that and lose these marks, which you would have easily got it in your pocket. So please don't do that. Yes, be careful, be careful. Okay, so let's get going to the next one. Now, yeah. Find the binding energy per nucleon for Sn, which is having atomic number 50 and atomic mass number 120. The mass of the proton is this, mass of the neutron is this, and mass of the tin nucleus is this. Binding energy per nucleon. Let's do this. What's the formula for binding energy per nucleon? Now, what is the meaning of the word nucleon? Nucleon means proton plus neutrons together is called nucleons. All those particles inside the nucleus are called nucleons. So this will be equal to delta mc square by number of particles. There are totally 120 particles. So 120. Now there is a simple way of solving this. You don't have to multiply it by speed of light and convert atomic mass unit into SI unit. There is a very simple way. You can write it as delta m into 931 mega electron volt divided by 120. This is an easier way for calculation, because you can see all the options are also in mega electron volt. You can do that. Yeah. Now the next step is, what the hell is this delta m? Mass defect. So think, guys, what is the difference of the masses? So there are how many protons are there and how many neutrons are there. Think about it, and then subtract the total mass of protons and neutrons from the mass of the tin nucleus. So what we are trying to do, I'll explain. There are protons, okay, there are protons like this, and there are also neutrons. Add their masses and then see what is the mass of the tin nucleus. Subtract them, you will get it. So remember one more thing. People will think, sir, if I add protons mass and neutrons mass, won't I get the same mass, 119.90211? No, this is the catch. If you have protons and neutrons individually and you weight, and if you have the tin nucleus, this is the SN, okay, the nucleus, which one will be higher? Just tell me this, which one will be higher? The left one or the right one? Whose mass will be higher? If you have 50 protons and 70 neutrons, you have 50 protons and 70 neutrons. If you weigh it separately, but if you weigh the same thing inside the tin nucleus, will they be equal or more? One of them will be more, one of them will be less. Will they be equal? What do you guys think? What do you guys think? Come on, my warriors. Rakesh, if you're poor at calculations, then you will face a lot of difficulty, not just now, but also ahead. So people who are generally quick at calculations are also very smart in life, and you will be also very sharp. I know in engineering you will make use of calculators, but basic calculations you should be able to do. If you are not used for calculations, then it will be a big problem. They are not equal, understand? This one is always more. In fact, this was also one of the questions which was asked. People thought that it should be equal and they got -1 marks. These masses individually are always more than the mass collectively. The reason is when they combine together to form a nucleus, some energy is liberated. That's why this mass is less, and remember there is some energy which is going to come out. So that's the binding energy. So individual protons and neutrons, more mass, but when inside the nucleus, less mass. The difference, mass defect, and that mass difference goes into energy released. Understood? Great. So this one is less and this one is more. Keep that in mind. So what will be the value of delta M, guys? There are how many protons? 50 protons. So 50 into 1.00783. I'll just remove this. I don't need this anymore. Plus, think about it. How many neutrons? Neutrons are 70. So 70 into 1.00867 minus. Why minus? Because come on, this was the total mass individually minus the mass of the nucleus. What is the mass of the nucleus? It's this one. So 119.9021199. This entire thing, okay, multiplied by 931 and divided by 120. 931 and divided by 120. When you solve that, you will get the answer. Yeah, that's how you need to do. Be careful with what you should subtract with what, else nothing will happen. You'll just get a negative answer. It's fine. I mean, you would know that the answer should be positive. You will just take the mod value, but you should know who is more, who is less. 50 protons, 70 neutrons, total mass before, minus the mass inside 10, multiplied by 931 by 120, because we have just done that calculation, and you will get the answer. Okay, so the calculation, I'll leave it up to you. Do not use calculators, remember that. The answer comes out to be 8.5. 120 kaise aaya? It was binding energy. Read the question. What is the question? Binding energy per nucleon. How many nucleons are there? 120. So delta M C square will give you total energy for the total nucleus. So per nucleon. So divide that energy by 120 because there are 120 particles. Yep. Okay, cool. You can take it as one, but then it depends. The answers are also very close. So I would not take that risk, music stories. Okay, don't take that risk. Come on, my warriors, let's go to the next question coming up on your screen. Now this is something which I feel you can do this, not very difficult, Not very easy. The radioactive nucleus decays by two different processes. Half-life for first process is 10 and for the second process is 100. What is the effective half-life of the nucleus if both processes are happening simultaneously? Come on, my warriors, figure this out. There are two processes happening on the same nucleus. It is decaying by two different ways. So you have a nucleus and it's decaying via two different ways. Okay, way number 1 and way number 2. The question is, what's the effective half-life? How are you going to, is there a formula for this? No, there is no formula. There is only one thing. The total rate dN by dt is the rate of decay, okay, by the first method or the first process plus dN by dt of the second process, because both are happening, so it will decay by first way and the second way. So the total rate is dN by dt of 1 plus dN by dt of 2. Now what is dN by dt? Well, that's lambda 1 into n, and dN by dt is also lambda 2 into number of nuclei. I know the minus sign is there, but it will get cancelled on both the sides, and this will be lambda into n. Can you see n goes? So this is the lambda effective is just lambda 1 plus lambda 2. So one thing you can do is remember this formula. It is very helpful. Hello, welcome aboard Kunti. Kunti is from Dubai. Yep. This is 12th standard class, Raj Sahib. This is not 11th standard or 10th standard. Yeah, this is the last chapter of 12th standard. So remember this formula. When parallel processes happen, then the rate constants will just add up for radioactive decay. Now what is the formula for lambda? Log of 2 by T half. So just use that. ln2 by T half for that process is ln2 by the for the first process. What is the T half? It's given to be 10 seconds. For the second process, what is the value of T half? It's 100 seconds. Do you see log gets cancelled? And what will you get? 1 by T half is 1 by 10. And I can take LCM, in fact, 10 plus 1 divided by 100. So therefore, T half will be 100 by 11. 100 by 11, guys. What should be the answer? Yep. Is it not 9? Yes, very good. Approximately. It's close to. It's not exactly 9, but it's close to 9 seconds. That's the answer. That's how you need to do it. So the important thing that you learned today is this one. Whenever two reactions are happening simultaneously, the rate constants will add. If there were 3 processes, it will be lambda 1 plus lambda 2 plus lambda 3. Keep this in mind. Very, very important formula that you learned just now. Okay? Great. Let's get going to the next one. Okay. So T effective will be 1 by T1 plus 1 by T2. Not minus 1, Rakesh. No, it will not be minus 1. Okay. Let's get going to the next one. Okay. The answer was there here. Let's see whether you can solve this question. Come on, my warriors. Figure this out. What will be the answer for this one? At some instant, there is a radioactive sample which is having some activity of 5 microcurie. It's some activity. Don't worry about the units, because the units are not going to matter in this question. And it has twice the number of nuclei as some other sample which has an activity of only 10 microcurie. What is the half-life of both of them? Beautiful question. Come on, think about it. How are we going to do this? Jayant, that's a wrong strategy, bacha. Theory should not be covered. If somebody is doing theory now, probably they are doing it wrong right now. You should not refer to theory. That's the worst mistake which JEE aspirants do. Sir, at the last moment, sir, let's revise theory. You have to do it on your own. What we should do is probably only revise formulas and the concepts around it. And that I'm going to do on Sunday. Sunday morning, I'm revising all the formulas and the concepts around it. That's entire syllabus. But right now, please don't sit and read theory. You're wasting your time. You should be solving problems. Understand? That's the worst mistake you can do. Don't do that. Raj Sahib, you're in 10th. My God. Raj Sahib, I'll see you next year, bacha, but you can watch the lecture for free, no doubt. I don't know how much you will understand, but it's okay. Okay, some of you are saying C, some of you are saying something else. Come on, B. Figure this out. Option A. Very good question. I have given you some time. You will not get more than 1 or 2 minutes out here. Okay, cool. Let's solve this question. At some instant, a sample S1 has activity which is 5, which is having twice the number of nuclei as the other sample. Okay, is there some formula for activity? Okay, now what the hell is this activity? Activity, simply put, is nothing but the rate, dN by dt. Okay, the rate, that's basically the activity, and okay, this is the modulus, and that will be nothing but lambda into the number of nuclei. Now the question is on half-life, and we know that half-life and wavelength, not wavelength, the activity, the decay constant is related by log of 2 by T half into n. Okay, so that's how it is related. Now the question is on half-life, so just take it over there. So T half will be ln2 into n divided by activity. Hence, I can do this. Ta by Tb will be Na by Nb into activity of A and activity of B over here. Inversely related, that's how I get it. Now, a lot of you are saying A out there. I don't know. Let's figure this out. Na by Nb. A sample S1 has twice the number of nuclei as the other sample. So this Na is twice. Understand, the first number is 2 by 1. Okay, that's non-negotiable. I mean, that's obvious. AB by AA. B's activity is 10. A's activity is 5. Okay, A's activity is 5. So this is 10 by 5. So is it not going to be 4, guys? So Ta by Tb is 4. So 4 times. Which option is correct? I think only B option is correct. B option, guys. Check this out. 5 and 20. 20 and 10, 20 and 5. No, this is 1:4. I mean, you want 4:1. Be careful. Yeah, be careful. Okay, is that clear? Shall we go ahead? Yep. Cool. Let's get going to the next one. Yeah. Oh, wait a minute. Wait a minute. I think the answer marked over here was wrong. Hold on, guys. We just got Ta by Tb was 4:1. We just got it as 4:1. So half-life of A should be 4 times more than that of B. That means this should be the answer, guys. This should have been the answer. Correct. Yeah, this should have been the answer. Yeah. So I'll just change the option over here. This was wrong. Hold on. Yeah, so that when you get your PDF, it's in the corrected form. Okay. So I'm just changing it over here so that you get the correct PDF. Okay. Sorry. Yeah, my bad. Let's do this. Let's get going to the next question. Yeah, the half-life of radioactive element A is same as the mean half-life of other radioactive element B. Initially, both substances have the same number of atoms, then only one of them is correct. Think about it. The half-life of two radioactive elements, come on, think about it, of radioactive element A is same as the mean life of other radioactive element. Initially, both of them have the same number of atoms. Come on, figure this out. Jagdish, these are the level of questions for JEE Mains. Okay, you will get difficult questions only in electromagnetism and in mechanics and in optics. Nowhere else you will get it. No problem, Raj Sahib. I'll see you later on. Okay. Preksha saying C, Partha saying D. Come on, my warriors. Hello, Shalambi. Welcome aboard. Come on, my warriors. Think about it. The half-life of something is equal to the mean life of something else. So, T half of A is T average of B. Half-life formula, what is the half-life formula? That's log of 2 divided by lambda. And Average formula is just 1 by lambda. Remember, half-life is not the same as average life. Be careful, guys. A lot of people make that mistake. Some of you are saying C, some of you are saying D. Okay. Yes, Pramesh, correct. Now, just rearrange. Lambda A will be lambda B into ln 2. Ln 2 is 0.693. Don't you see? Lambda A is less than lambda B. Therefore, dN by dt, the rate of that reaction of A, will also be less than dN by dt of the rate of reaction of B. Don't you see that? So where is it? A and B are at the same rate? No. A and B are at the same rate initially? No. A will decay faster or B will decay faster? Which is the correct option, guys? Yes, B will decay faster than A. Lot of you said C. That's wrong. It will be D. I just showed you A will be slower. So one which has less lambda will have smaller rate. The one which has more lambda will have a faster rate. So B had more, so hence it will decay faster. Yeah. That's how it is. Sanjay, you need to study for 10 hours every day if you want that. Okay, next question coming up on your screen. Some of you were saying A also before this. I don't know how you said A. Let's see how many of you can get this. There is a nucleus with 92 atomic number. There is a sequence of events which happen. Alpha particle emitted, beta particle emitted, beta negative, alpha, 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 beta negative, alpha. There is a comma here that's missing. Beta positive, alpha. What is the final Z of the resultant nucleus? Let's see how many of you can do addition and subtraction. It's nothing but addition and subtraction. You should be able to get it. Come on, my warriors, figure this out. Come on, figure this out. Just quick calculation, just add and subtract the numbers, you will get it. Nothing great about it. Okay. Let's see how many of you can do this. Here is the way. Alpha, what will alpha do? Alpha will decrease the atomic number by how many units? 2 units. Beta negative, what will it do? It will add or subtract. Think about it and just count it, guys. Count the number of alphas. How many alphas are there? How many betas are there? Beta negatives, and how many beta positives are there? Just count it first. Just count it. If you're not able to count it, then it will be a problem. Just count it. So let's count this. Alpha 1, 2, 3, 4, 5, 6, 7, 8. Alpha is 8. Did you see that? Now check what is beta negatives. 1, 2, 3, 4. So beta negatives are 4. Beta positives 1, 2. That's it. So the new Z will be the old Z, which is 92, minus each alpha. How many are there? 8. Each of them will reduce it by 2. Keep this in mind. Yes, it is going to reduce it by 2. Yep. And the beta positives and beta negatives. The beta negatives will increase it by 1. It will increase it by 1, and beta positive will again decrease it by 1. There are 2 of betas. So just do that and let me know what is the answer. Come on. Is it 76, 78, 82? This is very simple. Please don't make a mistake in it. 16 is there, then you have 4, and then you have 2. 92 minus 16 plus 4 and minus 2. What's the final answer, guys? Is it 76, 78? Pakka? B? Sure? Yeah, that should be the answer. That should be the answer. Come on, do that. 78. You should get this. Thank God you guys got it. Yep. So do not make a mistake in beta minus and beta plus. A lot of people make a mistake in beta minus and beta plus. So beta minus, understand, will decrease. Beta plus will increase. What is exactly beta minus? Beta minus is nothing but electron. What is beta plus? Beta plus is nothing but a positron. It's his twin brother. It's twin brother. Vikram, you'll definitely get a lot of colleges. Don't worry. Yeah. Let's see how many of you can get the next question coming up on your screen. The plot of the number of decayed atoms versus the activity of a radioactive substance is given by, best represented by which of the following graphs? Think about it. The number of atoms decayed versus activity is best represented by which of the following graphs? Figure this out. It's not that difficult. Come on, my warriors. Figure this out. The plot of the number of decayed atoms versus the activity of the radioactive substance. This is very simple. I have told you what is the meaning of the word activity. It's nothing but rate of decay. That's the meaning of activity. And we all know rate of decay is dN by dt magnitude wise, and that is lambda n. Don't you see A and N are directly proportional? Don't you see it is directly proportional? So there is only one option like that, and that is B. Do you see that? It is just B. No, it is not A. This is inversely proportional. This is constant. This is something else. No, it's directly proportional. So the correct answer should be B. Yes, it is B. Okay. Let's get going to the next question coming up on your screen now. Oh my God, some scary things are there. Don't get scared. It is actually very simple. Given the masses of different particles, this, neutron, electron, antineutrino, deuteron, which of the following processes is allowed by the momentum and energy conservation? Come on, don't get scared. Trust me, it's very simple. It's very simple. You don't even have to worry about it so much. Don't worry about these values so much. Oh my God, Aishwarya, which standard are you in? Okay, but still, okay, no problem. You can definitely watch the replays, Aishwarya, in case you found anything difficult. Come on. B, A, C, D. Rohit is saying B, Vedant is saying B. Ruchita is wondering, Yogesh is saying B. Okay. Which of the following process? Guys, come on. Deuterium is isotope, right? So a deuterium will have one neutron and one proton. That's what a deuterium is. So if you take one neutron and one proton and make a deuterium, you will obviously have some energy which is going to be liberated, and there is only one such reaction which is telling you that. As simple as that. You don't even have to worry about other things. Other things are wrong. So in your H.C. Verma, so check out all these reactions. H.C. Verma, you will see all the reactions which are pertaining to nucleus. So look at all the nuclear reactions. It's very, very important. Nirmal, sorry bacha, this is the English channel. So C, a lot of people went wrong. Yeah, some were saying B, D, something and all. No, it's C. Okay. So go to H.C. Verma, look at all those reactions which are given. Proton, antineutrino, electron, everything is given properly. You can watch it, you can read it, and you can brush up. Trust me, it's not that difficult. You can just go ahead and check it out. Okay, so let's take a small break. I also need to just take a little bit of rest. I'll just grab some pakodas, I'll just drink some tea. Don't worry, we are not going anywhere. What are the three topics which are left? We are going to see semiconductors, we are going to see logic gates, and then we are also going to see communication systems. So guys, I'll be seeing you back in some time. And that is put up as a countdown timer out here. Okay, a little bit larger break of 17 minutes. 17, Satra, Khatra. Okay, 17 minutes break, guys. So that's it. I'll see you in some time. Hello, welcome back. Hello everyone. You know what I was just doing? Apart from grabbing some snack, I was also calculating the time delay between actual session and by the time it actually reaches you. Any guesses? What's the time delay between, what's the time difference between when I actually conduct the sessions and by the time it actually reaches your screen approximately? Any guesses? Hi Kutha, hi Jyoti, hi Dheeraj. Welcome back. Yes, the break time is over. Hello Madhav, Apeksha, come on, join in. Oh, by the way, I just realized that whatever I'm saying will also reach you after some more time. By the time you actually tell me the delay, it will be more that delta t time. Yo, let's start. Any guesses? It take a while, guess. 15 seconds. I don't know whether I should show you my screen. Yeah, but this is me watching it right now. And probably, I don't know, it's very small. I don't know whether you can see it. If you see the time delay, you can, I don't know whether you can see the small screen out here. This is where I'm watching myself on YouTube, and look at the actual screen. You can clearly see there is a time delay. Okay, probably, I don't know, it's probably not clear. It's a time delay of 20 seconds. 20 seconds, yeah. 20 seconds, that's the time delay. Let's get going. Okay, ready for semiconductors? Put some fire in the chat box. Hi Yashwant, hi Kayali, hello Kota. Let's get going. Put some fire in the chat box, light the chat box by that fire emoji, because this is the last leg of our today's marathon session. Semiconductors is remaining, logic gates and all of that, and then communication system. Lots few questions coming up on your screen. Yes, Ashwant, this is also helpful for NEET. Okay, let's get going. Okay. Screen inside screen inside screen. That would be amazing, right? Yeah, more 45 minutes or so. Okay, let's get going. Here's the first question. The coefficient of thermal resistance for a semiconductor is? The coefficient of thermal resistance. Think, how is thermal resistance coefficient dependent on temperature? Oh my god, I can see the fire coming in right now. Thank you. 20 seconds delay. That's how it is. Welcome back, Ravas. No problem. Even if you're a NEET aspirant, you can still watch it. The chapters are roughly the same. Okay, HCB is already waiting for logic gates. Is it positive? Is it negative? Well, you should know this fact that, you know, if you increase the temperature for a semiconductor, then the resistance decreases, and that's why the value of alpha, the thermal coefficient, is negative. This is for a semiconductor. But for a conductor, when the temperature increases, resistance increases, conductor, not semiconductor, and alpha is positive. Understand, this is for conductors. This is something which you should remember. This has been asked again and again repetitively in the JEE Mains, NEET and BitSat and so many other examinations. So the answer is negative. Yep, beautiful. Let's get going to the next one. For a transistor to act, which of the following should be correct? Only one of them should be correct. Think carefully. Only one option is correct. For a transistor to function the way it is. So what is the basic principle of a transistor? See, those of you get confused, remember one thing. Okay, so this is a transistor, and let's say this is emitter, let's say this is the base, and let's say this is the current. This is like a valve where if you make any small changes in the base current, the collector current is drawn more and the emitter current changes by a lot of amount. A small change in the base causes a large change in the emitter current. That's the basic idea of a transistor. So if you cut out the base current, the emitter will also go away. If you make variations, the emitter current also varies, but by a larger amount. Always emitter current is much larger than the base current. That's how a transistor works. Now, which one is heavily doped, which one is small, which one is big, Yes, Sai Niklesh, every now and then there has been a question on semiconductor and electronic devices. Let's see. Okay, come on, let's figure this out. Parv, it's my wish. I can eat how much ever I want, and I might become fat, I might become thin, it's my wish, okay? You're nobody to tell me. Let's do this. Okay, so collector is heavily doped than base. Well, this is always true. But is it necessary for the transistor action? No. The actual reason is the base must be narrow. This is a fact, but that is not needed for the transistor action. Now I'll tell you why that is not needed. See, if I draw the transistor, probably you'll get some idea. Okay, so this is the base, this is the collector, this is the emitter. Okay, these are the terminals of the transistor. Now, what happens is when you apply a potential difference, voltage difference, if you apply a voltage difference between the emitter and the base, what happens is the electrons or whatever the majority charge carriers are there, they will begin to flow because of that potential difference. Okay, it's generally forward biased. Now once they reach the base, okay, in the base, let's say this is NPN, for example, this is N, this is P, and this is N. So these electrons have begun to move. In the base, there are holes. What do these holes want? They want the electrons. Some of those electrons will fill the holes. But what will happen is, because there are large number of electrons here, there are not enough holes to be filled. Number one, there are not enough holes to be filled. That is number one. Number two, these electrons, because of that acceleration, because of that momentum, and because of this tiny gap, they will overshoot. They will overshoot and fall into the collector. They will not get a chance to go over here. These are very, very few in number. Most of them will overshoot over here, because by the time they realize, yes, we could have gone here, you know, by the time they realize, it's too late. In fact, this is always forward bias, if you remember. Okay, this N is connected to negative, base which is P is connected to positive. So actually speaking, the electrons would love to go to the positive side because they will be pulled. This negative potential will push the electrons. That's the reason why these electrons are trying to go away from the negative terminal. They're trying to go away like this. But this space is so less that most of them go on the other side. Hardly a few of them go over here. And that's the reason why a small current, the current in the base is very small. And that's the reason why the collector or the emitter currents are very large. Understand that. Is that clear? So this is the basic functionality. This is the way in which it will work. So keep this in mind. So the electrons, the majority charge carriers in the N will overshoot because of the small gap. They will hardly get an opportunity to go to the positive side. That's what has happened. Cool. Let's get going to the next one. This is a fact, but that is not needed. Okay, the answer is C. Let's go to the next one. Now, in a NPN transistor, the collector current is 9.9 milliampere. 99% of the electrons from the emitter reach the collector. The emitter current and the base current respectively are. Sir, which channel would you read? I am reading both, Amit. Okay, I am reading both of them, catalysis as well as JEE Enthuse. Okay. Now, yeah, this is 12th standard class, man. Come on, figure this out. Now, first of all, if 99% of the electrons from the emitter reach the collector, what it means is 99% of the electrons from emitter, that means current of emitter, is basically reaching the collector. This is the collector current. Now, do I know anything? Yes, the collector current. The collector current is 9.9. Okay, so basically 99 by 100 of IE is equal to IC, which is 9.9 milliamperes. So what will IE be equal to? Take this on the other side, this will become 0.1, 0.1, and there you have 100. So that's going to become 10 milliamperes. So that's the first answer. The emitter current. The first question was what is the emitter current. Now the second question, what is the base current? Now you should know this, that when you have a transistor, there will be some base current, there will be some emitter current, and there will be some collector current. The collector and the base together give you the emitter current. So you should know that. So I emitter is equal to I base plus IC. I know the emitter current is 10. The base current is what I need to figure out, and collector current is just given to be 9.9. Isn't it obvious now that this should be 0.1 milliamperes? So where is it? 10 and 0.1. That's option C. Understood? Now guys, please remember one more thing. I know some of you have probably not read or gone through semiconductors. There are two things you need to do. Number one, watch this lecture properly. Even if you do not get anything, it's okay. Just try to understand how much ever you know. Even if you have studied little bit, it's okay. You will learn new formulas. Number two, watch the 0 to hero series on semiconductors. I have taught the entire chapter. So watch that properly. Trust me, there is going to be one question on semiconductor logic gates transistors in this examination. For sure you can get it. And it's a simple chapter if you only study the relevant stuff. Don't try to read the unnecessary stuff. Okay, just read the relevant stuff, you will get it. Okay, now this is a beautiful question. This can come in numerical type or even objective type. Now here is the thing. First of all, if you read the question, you will understand this is a question based on conductivity, mobility and all of that. Now you should know that formula, only then you can solve this. Now what the hell is that formula? How many of you know that? So the formula is something like this. Sigma is equal to sigma of the electrons plus sigma conductivity of the holes, and that's going to be E Ne mu E plus E N H mu H. This is the formula for conductivity of any semiconductor device, be it N-type, P-type, whatever, it doesn't matter. Now what is each of these terms? This E is the charge, sigma is conductivity, N is number of charges per unit volume. You can see that number of charges per unit volume and all is there. Oh no, in fact you have to find that. You have to find that out in this case. And mu is the mobility. Mu, E is mobility of electrons, mu H is mobility of holes. In the given question, neglect contribution of holes. That means this term is basically 0. Okay, fine. What is the question then? The question is, what is the number density of donor atoms? Now what is the donor atom over here? That's obvious, it's N-type. That means this is what needs to be found, Ne, number of electrons per unit volume. So therefore Ne will be sigma by E mu E. Now what is sigma? Look at this, 6.4 into, this is per centimeter. Since this is per centimeter, so for 1 meter it will be into 100, because this was per centimeter, so I have to multiply it by 100. E value is 1.6 into 10 to the power minus 19 into germanium diode's mobility is given for electrons, it's 4 into 10 to the power 3, 4 into 10 to the power 3 into, do not forget to convert this centimeter square into SI unit, centimeter square in meter square. 1 centimeter is 1/100th of a meter, so square of that will be 10 to the power minus 4 of a meter. 1/100th square, which is 10 to the power minus 4. You can clearly see, you can cancel this 1.64 and 6.4. Yep. And they will just have powers of 10. What is the power of 10 which is remaining? Let's see how many of you have already answered this. How many of you have answered this? Come on, my warriors, think about it. Let's see. If a circuit question is asked based on a diode and it is not mentioned whether it is ideal or not ideal, you should always take it as an ideal diode. Okay, so don't spam other students. Yep. D for sure. Think about it. Yep. Pramesh, it's 10 to the power 22. Very good. Most of you have got it. Yes. That's the answer, 10 to the power 22. You can see that. Okay, so remember this formula. En mu plus En mu is sigma. En mu plus En mu is sigma. Remember this formula, very important. Yeah, 10 to the power 22, correct. Let's get going to another question. Now this is also another numerical type. Guys, the thing is, you know, many people leave this kind of questions because they don't know the formulas. So please study these two formulas which I am telling you. Trust me, if that question comes, you can get it very easily. So don't leave this kind of formulas because these are very easy. For sure you'll get it. I mean, look at it, rotational mechanics, SHM, they have complicated concepts. If you know the formulas also, sometimes it is useless because if you apply the concept, if you know the intricate details, only then you'll get the marks. So it's a better thing where even if you don't understand much, but if you know the formulas and you get the answer, you should definitely attempt those kind of questions to maximize your marks. And this is one such chapter. Now, in these kind of questions, look at that. There is a pure silicon at 300 Kelvin, doesn't matter. The electron and hole concentration in each is equal. When doped with indium, the hole concentration changes. What is the electron concentration? Now, there is a general rule for hole concentration, electron concentration and hole and electron concentration in intrinsic. The rule is like this. NH into Ne is equal to NH into Ne. As simple as that, prime. So the product of the hole concentrations remains constant. This is the rule which you should know for any intrinsic or extrinsic semiconductor. Now look at this. The hole concentration and electron concentration is same for pure silicon. Okay, for pure silicon. And how much it is? It is 1.5 into 10 to the power 16. So it is the same thing, 1.5 into 10 to the power 16. When you are doping it, then obviously the concentrations will change and the hole concentration is given to be 4.5 into 10 to the power 22 into Ne prime. That's what has been asked. What is the electron concentration? So guys, Ne prime will be 1.5 into 1.5, 2.25. Okay, into 10 to the power 16, 10 to the power 16 will give you 10 to the power 32 divided by. You will have 4.5 into 10 to the power 22 over here. This was 32. Okay, so what are you going to get? Finally, just check this out. 4.5 goes with 2.25 as 0.5. Just think about it. Yes, Tarun, it's the same thing. It's the same thing. This is nothing but same as Ni square. In intrinsic semiconductor, it will be Ni square because both of them are equal. So N into N will become N square. It's the same thing. Okay, this is the same formula, Tarun. Don't get confused. Whatever you are saying is exactly the same thing. Is it okay? Don't get confused. Alright, what is the final answer? C for sure. Think about it. Or something else. This is going to be 0.5 into 10 to the power 10 and yes, so it is going to be 0.5 into 10 to the power 10, which is 5 into 10 to the power 9, which is option C. Correcto. Lot of questions, Ruchita, were covered today. Lots of them. Let's see how many of you can solve this. Two identical PN junctions are connected with a battery in three different configurations. The potential drop across the two PN junctions will be equal in which particular scenario? In which scenarios do you think voltage drop across both of them will be same magnitude wise? So three circuit diagrams. Look at the PN junction diodes carefully and then try to answer. One or more scenarios have same voltage difference across both the diodes. Which one are they? Tarun, I hope you got it. Okay. Pranjal, you can do one thing, on Amazon if you go, right, Pranjal, you can order those shades, blind man shades, or you can even order shawl or even you can order for long hankies. So what you should do is just go to Amazon, Prajwal Agarwal, order it and just put it on your face, like hide, like close your eyes using that. It's very good. So what happens is after that you will not be able to see my hair and you will not even feel whether it is good or bad. That's the best thing you can do. Just order it. Trust me, it will really help you. Yeah, it helps a lot. You will not have problems only in life. Sarthak Bacha, start answering, then I'll probably take your name even more frequently. Rishita saying B, Archit saying B, Charan also saying B. Let's see whether you guys are correct or wrong. Actually, it is B. Yes, it is B. I'll tell you why it is B. See, 2 and 3, the second and the third circuit, this diode and this diode both are in forward bias. Both are in forward bias. In this situation, both of them are in reverse bias. In this case, this is in forward bias and this one is in reverse bias. So, what happens in this situation? Whatever will happen here will happen here. The voltage drop here and voltage drop here, this will be equal to this. The voltage drop here and the voltage drop here, this will be equal to this. But in this case, this drop, if this is something, this will be something else. So they both will not be equal. Hence the correct answer is circuit 2 and circuit 3. Correct. Yes, Tarun, correct. Ne into NH remains constant in intrinsic or extrinsic. That's the rule. Product of H and E remains constant. That's all. That's something which you should keep in mind. Okay, cool. Let's get going to the next one. Diode based question. Somebody was asking, sir, is the diode ideal or non-ideal? What should I do? So usually if the diode is ideal, the resistance is not given. But here you can see these diodes are non-ideal and clearly the resistance is mentioned, 50 ohms. Let's see whether you can find the current through the 100 ohm resistor in this circuit. Very simple current electricity based question. Okay. Cool. Come on. Come on, my warriors. Let's see whether you can get it. The circuit shown in the figure has two diodes. Figure out which diode is reverse, which diode is forward. If you get that, you will get it. That's very easy. Figure that out. Which diode is forward, which diode is reverse. Purushottam, probably more half an hour, bacha. The class will continue. Okay. Yes. So obviously you can see this fact that since this is positive, obviously the current will get blocked here. That's it. It will be blocked because it is in reverse bias. So whatever current will go here will only go through this diode like this, like this, like this, and it will come back. So it's just one circuit. Ignore this part. Now in this circuit, the outermost circuit, what is the voltage? 6. It is equal to I into R. Resistance is 100 plus diode resistance is 50 and that is 150. So I will be 6 by 50 plus 150, 200, 200 by plus 100 is 300. Yeah, so this is going to be 0.02 amperes. Is it there? Yes, option A is there. Can you see that? Oh, a lot of you are saying D. I don't know why you guys are saying D. The answer is A, guys. Be careful. Yeah, it's A. Ruchita, don't let the Josh die down. Come on. Come on. Buckle up. You need to have this much stamina. I am able to stand over here and I am teaching you. In spite of my voice being dead yesterday night, I gathered up all the courage, gathered up all the strength, and I am doing this for you. Come on. You guys are just sitting and watching the lecture. Now, so you cannot give up. You can do this. Let's see. Which of the following is not the use of a semiconductor device? Which of the following is not the use of a semiconductor device? Think about it carefully. If you know the application, you will get it. Purely fact-based, purely theory-based. Either you know it or you don't know it. Come on. Why the second resistor considered? Because Preksha, that was in forward bias. If you see the question carefully for the previous one, look at that. This was forward bias, this was reverse bias. That's why I have not considered it. Okay. Some of you are saying A, some of you are saying C. Now, Zener diode is actually used in reverse bias. If you remember, it's actually used in reverse bias for voltage regulation. This is correct. This is perfectly correct. Diodes are used for rectification. Yes, this is also correct. You would have seen rectification circuit. What is rectification? Rectification means AC to DC conversion is called as rectification. Okay, so you can use the AC circuit, you can have a diode, and you will see that if you measure the voltage, this will be DC. This is also correct. Diodes are used for filtering frequencies. No, this is wrong. For filtering frequencies, you use RC or LR circuits. You use RC circuits, not semiconductors. Transistors are used for amplification. Yes, in fact, that's the basic functionality of a transistor. It acts like an amplifier. Whatever base current you pass, it amplifies it in the emitter current. That's correct. Okay, I hope this is clear. Very good. A lot of you got it as C. Excellent. That's correct. Let's go to the next question. This is a logical operation. Not of 1 and 1 or 0 or 1 is how much? Be careful about the brackets. Solve it properly. Oh my god, who is freaking out? These questions are not from my class, so feeling bad. I'm not sure why, Chaitra, you are saying that these questions are not from my class, as in you are a 11th standard kid, I guess. I'm not sure. Okay, don't worry. I think you can solve this even then. I mean, this is pure logical based questions. Preksha saying A, Bhagwan saying A, Tarun also saying A. Oh god, is this a question? Yes, it is a question. Did people get it? Please tell me you got it. Somebody saying B also. Come on guys, you should be able to do this. What is 1 and 1? 1 and 1 is 1. 0 or 1 is 1. This 1 or 1 is also 1, but the not of it. Do not forget that not. Please don't mark 0.5. Who are those people who will mark 0.5 and yeah, it's 0. The not of 1 is obviously 0. The not, the negation. Yeah, be careful. Yes, these kind of questions are asked in JEE Mains, trust me, and you cannot leave this. Yes, correct, Aishwarya, correct. Thank you, Kaisha Kamrul. Thank you so much. Hi, PD. Kunal, some of them are past year questions. Some of them are the questions from different books. Some of the questions are from our own question bank. Some of them are from Tattva. So it's a mixture of all the questions. The combination of the following gates is which gate? You can see the gates. I'm not telling you which gate is that. There is a dot here. There is also a dot here. So A and B is the input. X is the output. What is the effective combination going to be? Oh my god, Sai Telugu, please revise. Okay, Shivraj is so happy he got the previous question. He also put +4 in the chat box. First time I'm saying +4 after a long time. All this while, 3 hours and plus I have been conducting this class. Nobody said +4. First time somebody is saying. Very good. Yes, Satvik, I'm much better, but I know that if I talk for some more time, my throat is going to go bad. Don't worry, not many questions are left. Only a communication system is left after this. Okay. So I'm glad I said 3 hours, but I'm almost like 3.5 hours. Probably it's going to go till 4 hours. Okay. So and is dot or is plus, Naveen. Okay. Well, the answer is and, guys. I don't know whether you saw this particular thing over here. Solve this first. Forget that. Just forget that. See what will happen over here. If you give some input like 0, 0 will come here also. 0 and 0, 0. But the not of that is 1. If you give the input as 1, 1 will come here and here. 1 and 1, 1. Not of that, 0. So what are you seeing? 1 becomes 0 and 0 becomes 1. So actually speaking, what kind of gate is this? This is nothing but a NOT gate. Is it not a NOT gate? It's a NOT gate. And do you see a dot over here? So actually speaking, what this is you have a AND gate, you have a NOT gate, that dot is that NOT, and another NOT. NOT and NOT cancel. Minus and minus cancels. So this is nothing but just this. And that's obviously a AND gate. As simple as that. Okay. Lot of smiles out there. Okay. And slowly people are starting +4. Prem Chand, even I am confident you will get good marks because you are attending my classes. Trust me on this. Guys, if you have been regular since the time our channel started, probably in October, it's been a couple of months, and if you have been following flash series, our mock tests, our sure shot, then zero to hero, then rank booster, I am so sure that you will get an amazing percentile if you not just followed but also practiced everything. Trust me on this. I mean, there is no doubt in my mind also that you will do well, for sure. Let's get going. Communication system, yay! Let's get going. Shreyas Singh, do I remember you from Instagram? Okay, there are a lot of Shreyas in my Instagram. But yeah, I guess you are one of them. And my name has become so common these days. Every guy's name is Shreyas these days, and the girl's name is Shreya or Shreya. I've seen one girl named Shreyashi also. My God. Yeah. Can I skip 5 chapters? Anantu, it depends which 5 chapters you are skipping. You cannot skip EMI, rotation, optics, and then something like momentum and Newton's laws, and then magnetism. If you skip all these, gone, done. Thank you, big man. Let's do communication systems. Get ready. The first question coming up on your screen is: in order to transmit a signal of wavelength L, the length lambda, actually this is not L, this is lambda, guys. Please read that as lambda. That's printing mistake. Okay, this is lambda. The length of the antenna at the transmitting station should be at least equal to Ruchita, more 15 minutes, not more than that. Okay. Music stories, probably you should watch the Zero to Hero session on communication systems. I have taught everything from this chapter. Please watch that. Trust me, it's very easy. Just watch that lecture and solve the questions. You will get confidence, and you will also get the marks which are required for the actual JEE examination. See? Yep, correct. So the length is always more than or equal to lambda by 4. This is a standard result which you should know. Many times questions have come on this direct question. You will see one more after this. Okay, let's get going to the next one. An audio signal is sent to a carrier wave of wavelength lambda. The power radiated from the antenna is proportional to. The power is proportional to. Think. Come on, my warriors. A signal is sent. The wavelength is lambda. The radiated power is again proportional to. Some of you are saying C. Some of you are saying, probably waiting for the answers. Okay, everybody is saying C. Come on. Think. Power is proportional to A. Sure? Alright. Well, let me tell you guys, very simple way to remember this. Power is proportional to amplitude square, number 1. Power is also proportional to the frequency square, but do not forget, frequency is inversely proportional to wavelength. Hence, power is directly proportional to 1 by lambda square. That's how it is. So where is 1 by lambda square? That's option A, guys. So these are the standard things. Energy, power, etc. are directly proportional to square of amplitude. They are also proportional to square of frequency. Frequency is inversely proportional to wavelength. That's how you get that. Option A. Correcto. Beautiful. Next question coming up on your screen, and there it is. An audio signal is sent on a carrier wave of frequency 30 megahertz. The minimum length of the antenna at the transmitting station must be. I just gave you the formula just some time back. If you remember that formula, that's it. It's going to be a cakewalk for all of you. Come on, think. This is very simple, guys. Very simple. So easy. The minimum length of the antenna is just, I told you, lambda by 4. And what is lambda? It is speed divided by frequency. That's wavelength. So just substitute speed of light. Because every wave will travel, electromagnetic wave will travel at 3 into 10 to the power 8. F, what is F? 30 megahertz. 30 into 10 to the power 6. 4 is over here. So this is going to be 10 by 4, I believe, which is 2.5. Yep, 2.5 meters. That should be the answer. You can see that. Option D. Very easy. Yes, Chitra, this is from 12th. Tired of taking break? No. Why will I be tired of taking a break? I'll be probably tired of taking a lecture. Why will I be tired of taking a break? No. Okay, let's get going to the next one. These kind of questions do come in JEE Mains, trust me. Let's see whether we can do this. This is also a beautiful question. There is a signal of 5 kilohertz frequency and it is amplitude modulated on a carrier wave of frequency 2 megahertz. The frequencies of the resultant signal are... Yes, these questions are from communication systems, bacha. Communication systems. Oh my god, Sanya saying +4. Very happy, Sanya. Great. Okay, come on, my warriors. No problem, Chitra. You can still watch it for fun. You can see what others are replying and you can just sit back, relax, enjoy the flight. Okay. Let's see. Guys, whenever you have an amplitude modulated wave, okay, you have an amplitude modulated wave, there are 3 frequencies, remember. One is the, carrier frequency. This is the carrier frequency, and the other 2 over here is carrier minus signal, and this is carrier plus signal. These 2 are called as the side bands. This one and this one, they are called as the side bands. This is the carrier frequency, and this is called as the bandwidth. Remember, do not forget this. So the carrier wave frequency, what's the carrier wave frequency? The carrier wave frequency is 2 megahertz. Mega is 10 to the power 3 kilo. So this carrier frequency is actually 2000 kilohertz. So the other 2 side bands will be 2000 plus or minus 5 kilohertz. So you will have 2000, you will have 2005, and you will also have 1995. And hence the correct answer is A. Yes, Sudhana, thank you so much. Okay, that's it. Faridar, I am thinking I will conduct a NEET level strategy very soon. Just give me some time, because now I am held up with JEE preparation. As soon as JEE Mains is done, I'll come up for NEET people, all the strategies and some sessions. Now, I don't know where I'm going to plan this, either on Catalysis or on One Imam's channel. Okay, one of them for sure I'll do something for you. Okay, because I love everyone. Yes, these questions are easy category. Arul, that's the best part. They are easy category. Okay, what category of questions they are? They are easy. But this also has one more category. No one cares. No one does this category. Everybody skips this chapter. So these are easy questions which are left out by all the people. They get less marks. What can I do? So if you solve this, you will get those marks. Okay, let's get going to the next one. Modulation. No, 4th attempt will not get shifted. Okay. The modulation frequency of AM radio station is 250 kilohertz, which is 10% of the carrier wave. If another station approaches you, hey, give me the license, what is the broadcast frequency you will allot? You are the manager out there. Sanya Bacha, can you do one thing? Can you just rewind back and watch the repeat? It's very simple. In YouTube also it is there. Even in a live session, you can watch the replay. Yeah. Again, +4. Very good. Come on, my warriors. Figure this out. I just told you. Okay, those of you who did not understand the previous question, you will again get it over here. See, guys, there is another AM. So what is the carrier frequency? Okay, so the modulation frequency of AM radio station is 250. That means my signal frequency is 250 kilohertz. This is basically 10% of the carrier frequency. If this is 10%, that means the actual carrier frequency will be 2500 kilohertz. That's the meaning of 10%. Okay, cool. Now, if you think about 2500, there is a range which will be occupied. What is the range? 2500 plus 250. 2500 plus 250, which is 2750. And the lower end, which is 2500 minus 250, which is 2250. So these are basically your side bands. All this is blocked. All this is blocked. Okay, so this is blocked by that signal. So whatever frequency license you will allocate will be outside them. So you might be wondering, sir, which one will we allocate? Come on guys, what is the answer? Some of you are saying C. Athira, this session started at 3 o'clock, bacha. Long time back. Long time back. One safe, this is obviously wrong. This is just at the edge, you will not do that. 2750 is also at the edge. Can you allocate 2900 or 2000? Will both be correct? Who am I? Already made a video on full mechanics just few days back. I hope you are there. Sunday or Monday, I made that video. Full mechanics, I just completed it. Okay, it's already done. You can watch that. And plus all my regular sessions are there for mechanics. You can watch any of those Pathfinder, Nurture or Flash series. A or C. Guys, understand, I think you should go with 2000. The reason is, if you go with 2900, the problem is a range of frequencies again gets blocked. Plus 250 and minus 250. So 2900 plus 250, 2900 minus 250. Now 2900 minus 250 is 2650. Don't you see it interferes, it comes in this band. 2650 will come over here somewhere. It's interfering. So you have to block that range also. But for 2000 that's not a problem, because even if you add plus 250 or even if you take away minus 250, none of them, this will just come at the edge of it. So hence the answer is B. I hope this is clear. Understood? So a lot of people are going to mark 2900 thinking, sir, 2900 is outside this range, sir. But don't forget, even this has a bandwidth. This also has a bandwidth. So even that should not overlap. Did you guys get it? Did you guys get it? How to solve this question? This is a very tricky question. A lot of people are going to make that mistake out there by choosing 2900. Be careful. Let's get going to the next question. And there it comes. A signal of frequency 20 kilohertz and peak voltage 5 volts is used to modulate a carrier wave of frequency 1.2 megahertz. And the peak voltage is 25 volts. The question is, what is the modulation index and what are the side frequencies? Don't read the options, just solve it and then figure out which options are correct. Okay, figure this out. What is the most intelligent thing to attempt in the exam? The most intelligent thing to attempt in the exam is the exam itself. Okay, chalo. Thank you, Sudhavna. I'm so glad that you understood motion in a plane and one dimension. Glad. Keep attending the Nurture series as well. Okay. So, Aryan says -1. Okay. Let's have a look. There we go. First of all, signal frequency is given. This is signal. This is Fs. And where is the carrier frequency? This is Fc. Now, I just told you this carrier frequency plus signal and carrier frequency minus signal, this whole range of frequencies get blocked in an AM wave. Hence, look at this, this is actually 1200 kilohertz. Okay, 1200 kilohertz. And the range of frequencies that will be blocked will be 1200 plus 20 and 1200 minus 20. So this is going to be equal to 1180 and this is going to be equal to 1220. So this is basically blocked. So the side bands are 1220 and 1180. And last thing for modulation index. Modulation index is amplitude of the signal upon amplitude of the carrier wave. Very simple. Amplitude of the signal, if you know the formula, you will get it. The amplitude of the signal is 5 volts. So this is 5. Amplitude of the carrier wave is 25. So just put it over here. So this is 1 by 5, which is nothing but 0.2. 0.2. Done. Ho gaya. So which is the answer, guys? Modulation index is 0.2 and that's B. Yep. Oh my god. How many of you would have missed this question, guys? It's very simple. Please go and watch my lecture in Zero to Hero series. You will get it. Okay, and revise through NCERT. Just study from NCERT. Nothing else is required. So today the same question came in your exam. Wow, very nice. Well, Kumar. Yeah, come on. So that's it from me today. Now there is a link for joining the test series. There are 20 tests, full length mock test series in the description box right now. You can go and buy that test series, because apart from the test series that we are doing on the channel, you need full length test series with proper timing, with discussions. Of course, everything is there. You can see there is a link for taking the test series, and this test series is not at 2000 guys. No, in fact you can get it for 800 rupees. This price is the old price. You can get it for 800 rupees using the coupon code SHCC. There are 20 full length test series with discussions, everything available. So if you don't want the crash course, that is. And there is another link out here for the crash course. If you want lectures plus solving, you can take either this one or this one. Doesn't matter. You can see if you take this one, this will end before the second attempt. Even this will end, but you will get probably even the older lectures out here. You can choose any one of them. This is not for 10,000 rupees again. All right. You can use the coupon code SHCC, and instead of 10,000, you will get it for 4,000 rupees. Test series are also included. Lectures are also there. Revision is also there. Recorded lectures, everything. If you want to use these lectures in the last moment. So, yep, it's completed. You are using -20 in communication system. Okay, let's see. Don't worry guys, even you can watch the recorded lectures of communication system, semiconductors, EM waves, modern physics, any chapter. You can watch all the recordings in the crash course. Do use the crash course to your fullest benefit. 4,000 is a nominal amount. Thank you guys very much for being here. It was a lovely session. I enjoyed it thoroughly. I know physically I was tired little bit, but mentally I was never tired. Trust me on this. My body might give up, but my mind and heart will be like, no, I have to take this lecture. I have to do this. I have to do more. Okay, I want to do this also. So, my mind and heart never actually gives up for you guys. Piyush, don't be nervous, bacha. We are here. Again, I'll be meeting you guys on Thursday for a special session, Coffee with Shreyas. And Friday morning, 9 o'clock, complete electromagnetism revision plus problem solving right from electrostatics, Gauss law, current electricity, capacitors, magnetic effects, magnetism, EMI, AC, all of these chapters combined. And then Saturday, a mock test, Sunday, formula revision, Monday, sure shot 60 questions for all of you. That's it. Thank you guys. Bye-bye. Take care. And if you have forgotten to hit the subscribe or the like button, please do that right now. And if you want to know more about me, you can check me out on my Instagram handle. That's Shreyas_Vedantu. Yeah, I keep posting all the cool videos out there. Take care. Bye-bye. Hasta la vista.